बस थोड़े से
मेरा प्लान तो बनाइए पहले अम्मी से बात करना Hello, everyone. Good evening. Sorry for the delay. Okay, I think we can start. Okay, so we discussed the remaining questions on yesterday, right? Yesterday we discussed them. I guess there were some questions that I noted out yesterday that we wanted to discuss today, right? So
So,
yes.
sir, can you explain the question which I posted on chat?
Achha, this one, the question that you have pasted in chat. Okay, we'll check this. Okay. Okay. I thought I won't be able to take the class today. The weather was so bad, but luckily, yeah, it got better. So I guess I'm not sure whether we'll have a class tomorrow. I guess we should be having one more class at least, right? Because yeah, we have 2 days on this month. Nowadays, I don't know what's happening in NCR, right? So some days there is earthquake, some days the weather looks like it's cyclone, right?
Sir, module test कब होगा sir?
Most likely it's there on this coming weekend, right? Mostly it's on the first Saturdays of the month. The first Saturday is on first, so I guess it should be on first, but it can be on
It's on April 4th, sir.
April 4th.
Yes.
So because I got the next module is starting from 5th April. That is same for all the modules. So I was expecting it to be a little bit earlier. So generally it is 2-3 days before the start date of the next module, right? But if you have got confirmation that it's 4th, then that is the date. You can ping your batch manager. He would have like the confirmed dates. The date generally gets confirmed beforehand, right? So there is no change in that because the next module is planned accordingly. Module test is 4th. Okay, just confirm with the batch manager. Just ping him today. Get this confirmed. Okay, so there was one question in the chat. Let's discuss questions today, right? So let's spend time today more on solving question, understanding these questions, right? The remaining ones. Okay, so if you have any questions that you want to discuss, we can take that up. Roman and teacher. So yesterday we solved 3 of them, right? So the string one, this is solved. We solved this one, AJ number. This is done. We solved array swap, so this is also done. Okay, so these were the few things that I mentioned yesterday. So let's start with these ones, right? Let's start with this. Okay, I'll start with we'll do spiral at end. Let's start with count substrings that are palindrome in a given string. What was on this? Substrings that are, okay, the second approach, right? Where we can expand it. Okay. How many of you tried this one? How many of you tried this question where you have to count the palindromic substring? You don't have to store the string, you just have to count them. You don't even have to think about distinct or something. Pascal triangle, we did it, right? Pascal triangle, both the questions I explained, I gave you the solutions as well. It's there in here as well. The solution is there. Right, so this is the Pascal triangle solution. This is like the Pascal triangle 1, and then I explained that Pascal triangle 2 as well. This is the solution for Pascal triangle 2. So let's start with this one. How many of you solved this one? So this one is something which I want to discuss. This is a new approach. Okay, see, if you have doubts in any portal question, anything such that, so that you can get cleared, right? You have a lot of alternative ways to get that cleared, right? So I'll focus on something that will help you in logic building or help you in thinking through the variations of the question, because that is something which you will get, right? So that is something which is helpful, more helpful to in module interviews. Okay, see. Okay, so see. So there are two doubts that you have. One is what I want to do is I want to solve variations of the questions that we have already done. So that will help you to think of how you can how you can think through this, how you can vary your solution, or how you can think through that solution. Now, if you have doubts on any specific questions remaining, right? So we have discussed enough questions. I'll try to I'll try to also discuss them if we get time. If let's say we did not have more sessions, we did not get too much time more, then to more much time, then you can again have the doubt. You have doubt sessions, you have chat support, you have n number of ways to solve the question, right? So let's do this, and if we get time, we'll do that as solve your questions as well, solve your doubts. But if not possible, you know the ways to get your doubts addressed, right? Let's discuss this one. So yesterday we did one question where we counted like the distinct palindromic substring, right? So what was distinct palindromic substring? So what we did was, we found out all the substrings. Okay, we found out all the substrings. We checked whether it is palindrome or not. Okay, let me write that in steps. Okay. So firstly, we found out all substrings. Okay. Secondly, we checked whether it is palindrome or not. Palindromic or not, right? Whether it is palindrome or not. Okay. And then so let's check, we checked whether it is palindrome or not. And if it is palindrome, what we did was we stored it in an array. Okay, let's simply write it. This was multiple step, printed the distinct palindromes. Right. Now, how did we do this? So, so firstly, is there any specific scenario where should we use boolean? No, just that if your value is just 0, 1 or something, you feel that you just need two values, true, false, you can use boolean. You can use integers in place of it, right? It is very common thing to use in 0, 1 integer in place of boolean, or you can use boolean. There is no specific scenario where you should be using it. Okay. Just a second, I'm getting one call. Okay. So now we did these three steps. We found out all the substrings. We checked whether it is palindrome or not, and then we printed the distinct palindrome. How did we print the distinct palindrome? We stored all the palindromic string into an array. We sorted it. We also had to print it in the lexicographical order, right? So we found out all the distinct palindrome. We sorted it, right, in sorted order. So there was a lot of operations that we did over here, right? Boolean is size 1, so that would obviously be better than integer, right? So if you consider memory, right, to very minute level, using boolean makes better sense than using integer or any other thing that just is representing two values, right? 0, 1 or something like true false scenario. Okay. Okay. So how to find all substrings of a string without using substring function? So that we did, right? So wahi to kara kal. So okay, distinct palindromic substring. So in this function, we did not use any substring function. We found out all the substring of the string. So you need to run a loop from 0 to n, and you create another substring, right? We use string builder, and you just append the new string, right? So this is giving you all the substrings. We do not use any substring function over here, right? I also told you not to use substring functions because substring function has a n square complexity, right? So generally try to avoid it. Even if you use a string like string concatenation, this would give you order n complexity. So the entire complexity would still be n cubed because of this operation, right? To find out all substring. But if you use any substring function, it would go to basically n to the power 4, right? So using that is bad in terms of time. So this is something which you can use. Okay. This is n2. No, this is not n square. So this is like n square, but this palindrome function is order n. If we don't need to just check, if you don't want to check palindrome, if you just want to print the substring, that would be n square, right? But if you want to do any order n operation, like here we are checking palindrome, so that is making it n cube. So this is n cube, but if you don't have to check palindrome, if you just have to print all the substring, that would be n square, right? So this is order n, this is order n, and this is the O1 operation. Okay. Yes, KMP or Robin Carp, that is order n. So that is string matching algorithm, right? I guess वो अभी नहीं है. We can cover that. ठीक है, चलो, since you pointed out there are two string matching algorithms. You can read through this. So this is interesting ones. One is KLP and one is Robin Carp. So these are two string matching algorithms. So I'll discuss about them as well. थोड़ा सा मैं idea तो दे दूँगा, ठीक है? Okay, so let's come back to this question. Now, what are the things that is not required over here? Okay, so we want to find out all substrings. Okay, this is something which we want to do. Do we need to check whether it is palindrome or not? Yes, we need to. Okay, so we want to count all the palindromic substrings, so we need to check it. Do we want to print distinct or in sorted order? No, we don't want to print distinct. We don't want to check sorted order. So this step is gone. Okay. Now these two steps are combiningly I just showed, right? It is n cube, right? So if you find out like if you just find out whether a string is there and then you check whether it is palindrome or not, this is an n cube operation. Now can we reduce it to order n square if we don't have to, if you don't want the string? अगर हमें string नहीं चाहिए, if we don't want the string, because I'm not interested in printing the string, I'm just interested in counting the string, right? So can we reduce this entire operation to n square? Yes, actually there is a way. Okay, so what we can do is, okay, let's think through this. Let's say we have a string s which is hello world or something like that. Okay, let's say we have this int n is equals to s dot length. Achha, anyone tried this question? किसी ने भी try करा with the logic that I gave you yesterday? Anyone thought through this? How can this be done in n square? No, no one thought, no one tried. Cambian Robin Carp, no, that's not in this mod. So that's I guess it would be an advanced algorithm, but I don't feel they are very advanced, right? We can understand them right away, right? उतना difficult नहीं है. At least hashing का थोड़ा concept है in Robin Carp. KMP can be done. थोड़ा सा we can think through. बहुत difficult नहीं है. But yeah, it requires, if you know already hashing, dynamic programming, all those things, so that will help you easily understand this. Okay, so we'll discuss. I'll give you at least some idea what it is, so that you don't know what there is something like this. Maybe you don't need them now, you can later learn it. Okay. Okay, so let's think through. So what we want is, we want to figure out the palindromic substring. Now, what did I tell you about palindromic substring? Since we don't have to store strings, okay, so I'll not be focusing about storing string or creating that substring. मुझे मतलब नहीं है that substring is getting created or not. I'm not even interested in creating any string. Okay, I just want to check whether any substring that I'm considering is palindrome or not. Okay, so I'll just move which string that I'm considering is a substring right now. So for example, I will start with considering, let's say, one length substring, which is h. And then I'll think, if I try to add more characters, if I consider like there can be two scenarios. So h is palindrome, so I got a count as 1. Okay, now from here there will be two scenarios. Okay, first is to find out odd length substring, and second is to find out even length substring. Okay, now how will we find out odd length substring, or how will we find out even length substring? So think it on this way. Then odd length substring, we would want to add one character to the left of it, one character to the right of it, and we'll check whether it is still palindrome. Then if it is palindrome, we'll keep on adding more characters to the left and to the right. So this would make, this is a 3 length, this is a 5 length. And if these strings are palindromic strings, then we'll keep on counting them. Once one of them becomes non-palindrome, if we find, let's say there is a over here and there is a b over here. So this is not palindrome. So we will not proceed any further to find out any more palindromic string. If this is palindrome, then we'll keep on checking for palindrome. Okay. Now, in case of even, what we'll do, we'll assume even length palindrome string. For example, here, let's say we'll assume HE. So is HE palindrome? No. If HE, let's say we got HH. If this was HS, so this is palindrome, right? So we can add more characters to the left and to the right, and we'll keep on again checking whether it is palindrome or not. If it is, then we will try to basically find out the palindrome. Okay. I know this won't make any sense. ठीक है, कुछ sense नहीं बना रहा. Let me write the code. Code is very simple to look. Okay, this won't make any sense. Let me once write the code and then I'll explain you again. Okay. So what we want to do is we will have two things to figure out, right? One is odd length palindrome, one is even length. Okay. So for odd length, this index is going to be I minus 1 and index is going to be I plus 1. And let's say count is equals to 1, which is the current character. We have counted it. It is palindrome. And let's say we'll run until start is greater than equals to 0 and end is less than n. We'll check. Let's look at this. Okay. Okay. Now look at this code and you will be able to understand this. See. So what I'm trying to do with this code is I'm trying to count all the odd length palindromic substrings. Okay. How is this code working? Just listen to this statement very carefully, right? Next 5 minutes and you will be able to get it. Both easy and not difficult. Okay. So see, what we are doing is we are starting with I equals to 0. Okay. So I is 0. That means whatever is I value, that is going to be our center. Okay. That is currently our center. I told that we'll take two index, start which is I minus 1. So start is minus 1, end which is I plus 1, and this equals to 1. Okay. So I initially took the count as 1. Okay. Let's do one thing. Yeah. Okay. So let's say we take the count as 0. Okay, we take the count as initially 0. And what I did over here is as soon as I initialize this, I increase the count as 1. Now, why did I increase the count as 1? We did not get any palindromic substring. We actually got one palindromic substring. Which substring is that? So H, the character at index 0 is a palindromic substring. Is H a single character palindromic substring? Yes. A string with length 1 is palindrome. So that's why I simply increase the count that this character is already palindrome. Okay. Now what else? What are the other palindromic substring? So we'll start by checking is start greater than 0? No. Is this true? No, this is not true. So we'll not enter the while loop. So there is no other palindromic substring that we can form by keeping H as center because there is no character to the left of it. Okay, so it doesn't make any sense. Okay, so let's look at the next iteration. It might help you to understand this what we are trying to do. Okay, so let's see what is going to happen in the next iteration. So in the next iteration, I'm going to get I is 1. My start is going to be 0 and my end is going to be I plus 1. Okay, so which is 2. So I increase the count. First, I increase the count by 1, which became 2. So which is that palindromic string that I just counted? I counted the palindromic string simply E, right? The E palindromic string I counted. Okay. Now I check this start less greater than equals to 0. Yes, start is greater than equals to 0. Is end less than n? Yes, end is also less than n. Okay. So what we'll do is we'll try to check whether the character at start, what is that character? Character at index 0, H. If this character is equals to the character at end, is this equal? No, they are not equal. So we'll break. That means this HEL is not a palindromic string. And now it doesn't matter if you keep on adding more characters to the left or to the right, you won't get any more palindromic strings. So we'll break over here. Okay. Achha. So let's create a palindromic string. Okay, let's try to create one. Do we have? Achha. Let's take this as L. Okay, so let's take this as L. Now see. So like same for I equals to 1, what is going to happen? For I equals to 1, you will get L. Okay, so we counted it, it became 2. Now we came inside, we checked, start is greater than 0, end is less than n. Okay, fine. We go over here, we check, is start equals to end? What is the character start? H. What is the character at end? That is index to L. Is these two characters equal? No. they two are not equal. So it doesn't matter how many characters you keep on adding, you will not get a palindromic string, right? So we did not do anything. We simply break out and we come outside of the loop. Now next iteration. Now look at this iteration very carefully. You will be able to understand what I am trying to do. So now when I becomes equals to 2, what we are doing is, see, I became equals to 2. My start is I minus 1, which is 1. My end is start I plus 1, which is 3. Now in this iteration, I first increase the count, which became 3, which is that palindromic string L, this L, right, at index 2. I counted this is a palindromic string. Now I check whether start is greater than equals to 0. Yes. Is end less than equals to n? Yes. So I come inside. And what I do over here is I check, okay, what am I checking? I'm checking is start, the character start is equal to the character at end. What's the character start? Index 1, L. What is the character at end? L. So is this equal? Yes, this is equal. So what we do is we increase the count. This is a palindromic string that we found by adding one character to the left, one character to the right, and we decrease the start and we increase the end. So we decrease the start became 0, we increase the end, it became 4. Now look at here, what is going to happen at the next iteration. So this is going to not break. We're going to check is start greater than 0, yes, and less than n, yes. So both of them are true. Now we come inside of this loop and we take the character at index 0, which is h, and the character at index here, which is o. Now, is these two characters equal? No, these two characters are not equal. Character start and character at end are not equal. So we break the loop. So this was not palindrome. So see, what is my simple strategy to verify whether a string is palindrome or not? Hello. Okay, sorry. So see, what I am trying to do is I instead, let's say this is a palindromic string, right? So how did you know that this is palindrome? One way you did was you firstly tried to reverse this string. You checked whether the reverse is equal to palindrome or not. Okay, fair enough. Other way I told you is you can start by comparing last two characters, these second and second last character and the middle character, and you'll say, okay, this is palindrome. Now I'm giving you one third way to find out palindrome, whether it is palindrome or not. See, how can you do it is by now the same string. Let's take the same string and I'm telling you start with the middle character. Okay. Now just move to the left and compare these two characters. If these two are equal, then it can be palindrome, right? If these two characters are equal, then it can be palindrome. There is no more character to the left and to the right, so this is a palindrome string. This is the last palindrome string that you can find out. So what we are basically doing is we are adding one character to the left, one character to the right. If they are equal, then that substring is palindrome. Okay. So how we are basically getting the substring C. So will it print all the substrings of the string? Let me show you, right? It will actually print all the substrings if I don't break, right? So if I don't break over here, okay. And let's do this. System.out.println. The start is start, end is end plus 1. Did I have an infinite loop? Start is decreasing and is increased. Oh, if it is equal, if it is not equal. Sorry. See. So firstly we got HLL. Okay. Start is 0. Okay, that's fine. Okay, check what we are getting. So the first character we got is H. Okay. Now we try to add one character start and then not possible. Because we do not do anything, we just ended over here. Okay. Next character that we got was L, and we tried to add one character to the left and to the right of it. Yes, we got. So this is the substring, right? So this is the substring that we found. Okay. Next, we could not add any more characters to the left, to the right of it. To the left of it, right, we can add. So we stopped over here, right? Next iteration, we got the second L. Okay. In the second L, when we got this L, we can add one character to the left, to the right. So that becomes LL, triple L. Now we can again add one character H and one character over here. So this becomes HLLO. Okay. So we are not counting, we are just printing all the substrings that we are forming, right? So this is forming all odd length substring by keeping the current character as center. So हमने क्या करा? We are picking one character, we are creating that its center, and then we are expanding to the left and to the right. And we're doing, okay, this is a new substring, this is a new substring. And if we don't have any more characters to the left of it, we keep, or to the right of it, we stop there. So for example, here we do not have any character to the left of it, we stop. Here we don't have any more character to the left of it, so we stop. Okay. Now check. Now for the next time when we are going to stop, so when we see the third L, okay, now we are on the third L. So we are keeping the third L as center. Okay, we keep the third L as center and we add two characters. One is L, one is O. So we get LLO, right? One character to the left, one character to the right. Next, we add one L and one space over here. So that is this particular thing, triple L, O and a space, right? The space is also there. We don't see it, right? Next iteration, we add a H and then the W over here. So this is that substring that we found, right? Now, understood? Acha, chalo, let's remove space so that you can see it better. Chalo, let's remove that space. Okay. Are you able to see it now? Achha, let's print the one length substring as well so that you can see it. So the string that we are counting over here, so that is a one length substring, right? So what is that one length substring? That is this simply s dot caret I. Okay, now check. Now look at this. So first one length substring that we considered was H. Okay. Okay, now look from here. So first we got I equals to 0. Okay. We consider the first one length substring, that is H. So this was the substring. We printed it even before counting. So this is a palindrome, right? One length substring is anyways palindrome. You don't need any verification. You don't need to do any check. It is palindrome, right? Whatever character it is palindrome. You don't, even if it is a space, it is a palindrome. Okay. Okay. Let's move to the next. So what we did after this, we created two variables. One is start, which is -1, and which is I plus 1, which is 1. So this is not satisfying, right? There is no characters that can be added to the left of it. So we told, okay, since there is no character that could be added to the left of it, let's stop over here. Okay. Okay. So we did not do anything. We just stopped over here. We just stopped over here, and then we went to simply increase I, which is I became 1. Okay. Now look what would happen in this situation. When we increased I to 1, start became 0, end became 2. Now, when I is 1, what is that string that we are getting? Character at 1. So the one length substring is simply L. So we get L. Next, once we get L, we try to add two characters to the start and to the end of it. So start character is start and end character is end, which is L. Okay. So we get HLL. Okay. Next, we decrease start by 1, we increase end by 1. So now this doesn't satisfy the condition. There is no more characters to add to the left of it. So we stop over here. Okay. We increase I becomes 2. Okay. I becomes 2, and then we try to find out all the substring with keeping the character at index 2 as center. So index 0, 1, 2. So this is again another L. Okay. So this is start is 1, end is going to be 3. We get the character at that index, which is L. So we get the second L, right? Which is the character at index 2. We printed it. Now, next first iteration of this loop, we are trying to add one character to the left, one character to the right. So it is LLL, that is the character, that is the substring that we form. Now, here we add one more character in the next iteration. This becomes 0, this becomes 4. So we add H and O. So this becomes the next substring. Okay. Now this becomes -1. We don't have any more string to add. So this is where we stop. right? We don't have any more characters to add to the left of it. Next iteration, we again get L, LLO, this and this. So we form again another set of substring. So, but this is only forming odd length substring, right? You can notice that it is either 1 or 3 or 5 because we are adding one character to the left, to the right. So every time we are starting with one length and then we are adding 2, 2, 2, 2. So it is going to be 1, 3, 5, 7 and so on, right? So it is always going to be an odd length substring. I'm not focused. I have not checked on even length. Okay. Now, what is the advantage of doing it in this way? I don't need to run an order and loop to check whether the substring that we are finding is palindrome or not. Why? Because we'll stop anytime we'll not find the substring to be palindrome and we'll only continue if the previous string is palindrome. Now, let's say LLL is palindrome and the new two characters that are added, if they are equal, then the new string is palindrome. If these two are not equal, then that is not palindrome. That we can right away say, right? Here, I'm telling, right, if we are printing the substring, did we ask, they're asking the question to print the substring? No. So you are not asked to print this substring, you just have to count. Now this count logic is order n square, sorry. Right? Now see, is this logic order n square? If we are not printing, if we are not storing, or if we are not doing anything on the string, if I'm not telling you to print the string, if I'm simply telling you to count the strings, is it a n square logic? Simple. Yeah. It is only for you all to understand. We are not required to print this. We are not, the question is not asked you to print it. That's why I told you, if it is asked to print it, if it is asked to store it, if it is asked to return those substring, then it will always be NQ, right? You cannot optimize it from there. But if it is just asked to count or do something like that, it can be optimized. And this is the way. Okay. Acha. So this is only considering odd length substring. Understood? We are not getting the correct count, right? Right now we're just counting odd lengths. So we have to count the even ones. If you understood the odd one, then I'll tell you how to count the even lengths. First, tell me anyone having doubts on this odd length substring. Now, is it clear how we are getting all that? Very simple, right? As a Soto, we are starting with one length. We are adding two characters to the left and right, right? So let's say we have started with saying a single length. Okay. We add two characters E and E. So if these two are equal, then it is palindrome. If we add two more characters A and A, so this is equal, it is palindrome. If you add one more character, let's say G and H. Now these two are not equal, so it is not palindrome. So now it doesn't matter. You add any number of characters, even if it is all A's and here it is all A's. You cannot make this string palindrome. You cannot create this string as palindrome by keeping L as center. You can move the center to somewhere else. You might get a palindrome, but keeping L as center, you will never be able to form a palindromic string. And we are moving the center, right? We are starting the center, keeping this as center, keeping this as center, keeping this as center, keeping this as center. So we are keeping every character as center, and we are trying to find out the maximum number of palindromes that we can create by keeping that string as the center, that character as the center by moving it. We don't need to find out the substring. So that is where we are saving time, because that is a costly operation. Now we just are checking the new two character, and that is a O1 operation to check, right? Whether a new substring is palindrome or not. We don't even have to run an order and logic to check whether it is palindrome or not. We can just check both the characters. Understood this? Clear? Now, can anyone tell me how can you figure out for the even length? It is very easy, super easy, not difficult. Think. So you just need to change this from I-1 to I, or and you can change from this, you can keep I-1, or this you can keep I. Any one of them will work. You don't need to do a count plus again. You already counted the one length. So you counted the one length over here. We are trying to count all the odd length over here, and this is where we are counting the even length. So see, now how it is going to generate all the even length substring. See. So what we are doing over here is, earlier we were starting the start and end with I-1, I+1. Now look at this logic, how we are starting the start and end. So here what we are doing is, let's say our I is at index, let's say over here. Okay, our I is at index as 0, 1, 2, 3, 4. So index I is equals to 4, I is over here. So we get this is the character. Okay, this is the character at index I. So what we are telling is start is I, which is 4, end is at index 5. So we are comparing is 4 and 5 equal. If the character 4 and 5 equal, if it is equal, then this is palindrome. It is not equal, so this is not palindrome, right? Okay. Let's check whether we will find the even length palindrome string over here. Yes, we'll get this as palindrome string. So we'll get an even length palindrome string by keeping L as center. Let's check this one. So L, this is, so let's say 0, 1, 2. We got I is 2. So we got start as 2, end is 3. So what we checked over here is the character start equals to the character at end? Yes, this is equal. So these two characters are equal. So this is the even length palindromic substring, LL. Okay. Now we are counting it and we are decreasing the start again by 1 and increasing it by 1. So now in the next iteration, we'll compare this L and this O. Is this a palindromic substring? Understood? Okay, let me print all the even length and odd length substrings so that you can get a clear picture of how it is working. So here, let's say whenever we are counting, right, I'll just print the palindrome once. S dot substring. This is start, comma, n plus 1. And we'll copy the same thing. This. Let's wait for that. Let me run this. See, so this is like the even length that we got. This is the odd length we got. So for every character that we are getting, so for example, we got this character. So we kept this as center, so it will give us all the odd length substring. And then we consider the middle, like there is no center. This is like middle character center, and these two strings are the center. These two characters are the center. So now that will give me all the even length. So there will be no duplication. So for example, let's say if I remove this logic, right, and check if what are the odd length and what are the even length substring these two loops are giving, there won't be any a single string that is overlapping in this. That's the beauty of this logic. You won't, since even though we are running it 2 times, you won't get any single substring that is overlapping. So for example, here you got all the odd length substring, right? So the first loop is giving you all the odd length. Now, so okay, for H there was no odd length, there was only even length, which is HL, right? And this is the odd length. You won't find any duplicate substring among both of them. Why? Because the first loop is giving you all odd length, so it is going to be 1, 3, 5, and so on. The second is going to be even length, 2, 4, 6, and so on. So if the length of the two strings are different that it is generating, how can they overlap? How can the strings be same? There is no possibility of they can be same, right? So there is no overlap of substring that we are generating. And we are doing the minimum number of comparisons to find out whether string is palindrome or not. We're not running any loop to check whether string is palindrome or not. We're not traversing any character even twice. If we add 2 characters, we right away check whether it is forming the current string as palindrome or not. If not, then we are stopping there. We are not even increasing the length of substring. Right? So if it is very random character which is not palindrome, then this logic will break almost every time after the first check. Right? Within the first check only it will break. Understood? Now is it clear what we are doing over here? Can we use it for distinct palindrome? See, if you use it for distinct palindrome, there you will need to find out substring. Now, once you find, so this like in this case, substring finding is even difficult. So if you use this, this is n square. So this entire logic becomes n to the power 4. Right now it is n square. See why it is n square? The first loop is order n. And I have written 2 loops which will be at max order n. So this and this loop will be order n. So this is 2n. So 2n into n, n square, right? So final complexity of this logic is n square, but we can simply count, right? If I tell you to store the strings, it is very difficult. If you use substring, that will make it n to the power 4, right? If you don't use substring, you can use string concatenation, but here you need to add 1 character at the start. So you have to add it in this way. Let's say you have to find out a substring. So how is the substring going to look like? You have to do this. S dot caret start plus the existing substring that you have plus s dot caret end. Okay. And this is a order n operation, right? This will be a order n operation. So this is n cube, right? So this would be a order n operation in each string concatenation. Okay. So this will make it again n cube. So there is no advantage of using it in for distinct palindrome. This just increasing the logical thinking. But if you are not asked to print the substring, then this is a very used bonus. You just have to count them, then this will give you the best complexity. So we just have to count them and print it, then you'll get it in n square. And this is a valid question where you'll get the constant like string is of length 10 to the power 3, right? So you cannot run an n cube logic there, but you can run an n square logic there, and this is going to work fine. in that scenario. So we got 14. How is count 14? So let's print all the strings. So 14 are right, so we should be seeing 14 palindromic substrings. Acha, 14 to aega, I guess. So these are like, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 strings over here. So these are so each character with a single length palindromic substring. So it is 10 strings from here, and it is 4 strings from here, right? So these are 4 other strings apart from a single character which are palindrome. Okay, we don't have any other palindrome, so there are total 14. Okay, I can validate this. This logic is going to be correct for any such string that you want to check. If you are not asked to print it, it would be n square. If you ask to print, then it will become n cube. How many days are required to analysis and logical thinking like this? I would say it would take time, right? So develop logics like these, it would take time. See, and now you would have understood that these logics are not difficult. See, do you feel any of this logic is difficult? Any of this logic is like, I cannot understand it, I cannot remember it, I can never learn this. It is not difficult. It's just that you require time and practice and practice on a lot of variations of questions. And if you see similar questions again and again, you might remember, right? So for example, see, initially when we started, we knew only one logic to find out palindrome. What was that logic? So we knew only one logic for palindrome, which was firstly reverse and check. So we reverse the string, we reverse the number, and we check. Then in case of string, we understood, okay, we don't need to reverse. In case of string or in case of array, we can use 2 pointers. One is at the start and one is at the end. And we can keep on comparing them by moving towards left, towards this would move towards right, and this would move towards left. If all the characters are equal, first and the last character, second and the second last character, and so on, right? Then it is palindrome. Now we just change this logic to little bit, and we told that let's start with between. Now there was one problem, that this string can be an even or odd length palindrome string. So if it is odd length, then we can keep this as center and we'll start and end would start over here. Okay. And if this is a even length palindromic string, for example, let's say, ma'am, this is an even length palindromic string. So I'm telling the start and end would start over here, not that the center would be this, which is nothing. And in this case, the center would be basically a character. Yeah, understand. Adding things into see, these things you'll gradually remember. Let's say these things you will gradually remember over the period of time as you solve more questions and variations. Okay, I'm just trying to show you how you can think. And this is just like thinking with different way, and you can get an n square logic for same similar kind of problem with a little bit variation, right? Agar wo distinct, if it is asked for strings, right, we cannot get away. But if it is not asked, just count or something, then we can get away, right? Okay, so I'll give you a few hints of how you can think through this these ways. See, till now, whatever questions we have solved on strings, you would have realized there is substring operation is very costly, right? You have realized at least one point that substring operation, in order to find out substring, is a very costly operation, right? And if you are finding out substring in such a way that, like for example, this, if you're finding it even in this way, this is easy because this is O1. This is not costly. But if you require to add string at the start or end, or let's not tell it substring, let's tell it string concatenation. Right? If you require any specific case of string concatenation, it is going to be a costly operation. Is there any way we can avoid it? We can avoid this string concatenation until you require that substring. If you have no use of that substring, if I have asked just to print the count, what use of that substring is to you? Can we get a solution without finding that substring? This is the solution. Right? If I tell you, no, we have to find out the substring because we have to print this string, we have to store them, then like basically we need to find out substring. There is no workaround for it. But if we can find out the solution without using string concatenation, that is going to save our time. And time is like money, right? So time is basically, if you save time, you save a lot of computation, your code improves, logic improves. Understood? Yes, no. So let's move to the next question then. Okay, go through this logic, not difficult, easy to understand. Okay. Hi.
Sir, sir, how to remove duplicate substrings?
How to remove duplicate ones? Yes, now that's a challenge, because in case if we want to remove duplicates, we'll need to store them, and if we have to store them, we'll need to find out substring. So that again makes it n cube, right? So if we have to do any other operation like removing duplicates, even would would need to find out something like this, right? So it makes it n square n cube, right? After doing this, if we check pendulum, it becomes n cube, right?
Okay, sir.
I guess there is one way. Achha, chalo, in this question, I guess there is one way we can. How many substrings will we have for a given string? How many substrings will we have? So we can trade time with space over here. I guess that is one classic thing that we can do over here. So we can trade time with space. How many substrings are we going to have for any string? How many substrings does any string have? N square. No, for that would be again. No, we don't think. I don't think we can do it. Can we do it? No, I don't think that is possible. So we can, I guess we'll have n square substrings. Now, among those n square substrings, if we remove all the duplicates first, it won't be like we won't get any like complexity wise, we'll still see n cube, right? So we won't be able to optimize it, and like those operations. Actually, see, I'll tell you how it works in real life scenarios. I'll give you some idea. So see, here is there is one more thing that we can do over here. So we can find out all the substring, that is n square, right? So till here the logic is n square. This is making it n cube. So what we can do is we can store it in a n square size subarray, n square size array list. Okay. And we can do this operation first. We can sort it, and then we can remove the duplicate. We can do this operation first, and on the remaining, and we can create a new substring which will not have, which will be sorted and which will not have duplicates. And now on that substring, we'll check whether it is palindrome or not. So basically, we'll reduce this from n square to some smaller length array, which is not having duplicates, which is not having this. But now it now the question is, do we actually need n square size memory to and we will get that much optimization? क्या हमें उतना optimization मिलेगा to get n square size by using an n square size memory? So for example, take this string as example. Okay. So there is a lot of duplicate substrings. So if you run this logic, what you are doing is you are basically checking for a lot. You are finding a lot of duplicate substrings, and you are checking whether it is palindrome or not, and your entire complexity is n cube. Okay. Now what you can do is you can find out all the substrings that is n square. So you'll get n square in n square logic and get all the substrings, and you can store it in an array list. So this array list size is going to be n square. This array list size is not n, it is n square, because it is storing n square substrings. So its size is n square. Now, what we can do is we can firstly sort this. So that would become n square log n. Okay. And then we'll try to remove all the duplicates. We'll remove all the duplicates. So this will basically reduce the size. Or we can do first thing, we can do this, and then we can remove all the duplicates. So this will make this will reduce the size, right? This will reduce, the array size would be still might be in order, but for example, string like this, it would reduce very significantly, right? There would be a very significant reduction in the size of array list. After this, if you perform a palindrome check, that would be so basically you're performing palindrome check on lesser number of strings as compared to what you are doing over here. But now, you can store it in Hashchat, but Hashchat again has a lot of problems. It is not sorted. Hashchat is sorted, right? Hashchat is sorted, but yeah, the insertion is log n there. So there is a lot of challenge. Yeah, this is, I guess, the best we can do. Apart from this, any other logic we go into, it will become n square log n or something like that in worst case, which is like which is not good, right? So this one is at least better than them. Okay, so this is the best we can do. If you have to, in any scenario, we have to find out the string. If you don't have to, then we can think of other ways. Okay, so let's move to the next question. We are asked to Hey, I'll check Shiva. Just a second. Let's go through this one. Then your questions I'll check. I'll check all of your questions. Short for duplicate substring. This one. For this particular question where we are counting it. So here basically you'll see. So see, here if we have a duplicates, let's say, let's consider a. So we have a lot of duplicate substrings. Okay. So if I run this, what you'll see is there is a lot of duplicate substrings. See, there is a lot of duplicate substrings that are forming A. This is also forming A. This is A. So this is a lot of, there is a lot of duplicate substrings that we are getting. Okay. And we are getting the eventual count is 40, right? Because there is a lot of duplicates and such thing is happening. Here we cannot remove the duplicates until we start storing the substring, and then we later perform some operation on it. And if we find substring, store it, becomes n cube. No possible way to reduce that. Okay. Clear? Let's see, move to the next one. Sort a string based on the length in case the length is equal, sorted in lexicographical order. How many of you did this? Yesterday someone told the solution even for this question. इसके लिए solution ही बता दिया था. So if you would, so this algorithm is fine if you are not asked to remove duplicates, you are not asked to count distinct, you are not asked basically to print substring, right? I told you, right? There are constraints. You're not asked to count, remove duplicates. You're not asked to basically print the substrings. Both of the things are asked, then you have n cube. That's fine. But if that is not asked, then you can use this one. Okay, how many of you got this one? इसका solution तो कल बता दिया था किसी ने. चलो, let's move to that sorting and I can cover that part. Where is bubble sort? So here we discussed yesterday, right? Yeah. So there's a sorting that we discussed, right? We can use either compare to, so sort them in the lexicographical order. We can use dot length to sort them in the length. Now I give you one constant key. Let's say we want to use both. Firstly, we want to sort them in the length order. Now, if the lengths are equal, then we want to sort them in the lexicographical order. Okay, so we did this. Now, what is the problem? If the lengths are equal, we are seeing some random order, right? A, X, B, Y, right? We are seeing firstly B and then A, right? So which is random order. If the lengths are equal, then we want to do something. So the solution is very simple. You need to do a simple else check. If AJ dot length, A of J dot length is equals to A of J plus 1 dot length, if the lengths are equal, then what you need to do is you need to just run the same logic, but you need to run the same logic, but with comparing the comparing the lexicographical order. That's it. If the lengths are not equal, if the length is greater, then we do this. If the lengths are less, then they are if the lengths are less, then we don't have to do anything. So the first criteria is length, right? The length should be in the correct order. And the second criteria is the lengths are equal, then we check them based on the lexicographical order, right? Now, if I run this, see, so when the lengths are equal, what you are getting is you are getting the strings in the correct order, A, B, C, X, Y. When the lengths are equal, you get AC, and then BC, and then finally ABC, right? So first criteria is sort them based on the length and then sort them based on the comparative function. Understood? Yes. Easy. And this is one of the most asked thing in interviews. Okay, so remember this, how to apply this sorting on length of strings, and when you have to sort them in the lexicographical order if the lengths are equal, right? Comparative function, okay. So what is comparative function? Comparative function is basically comparing two strings in the dictionary order. Okay. Now what does dictionary order means? See, you all know this order. Okay, all of you know this. There is nothing that we don't know over this. So for example, let's say this is one string and this is another string. So if I tell you to put them in dictionary order, you will say this is the first string and this is the second string. How did you figure out? Use a simple logic that you compared the first character. If this is not equal, then you saw, okay, which one is lesser, which comes first in the alphabetical order, this. So you say this is the smaller string, this is the greater string. So you are able to determine which string is smaller, which string is greater depending on the characters. Now if I give you the second character string as like this AC, you'll say still this is smaller. Why? The first character is same. Now the second character, it is comparing these two characters. It is telling, okay, if this is not equal, then which is smaller? So B is smaller, so the first string is smaller, right? If I just give it as AA, now you will tell the reverse. You will tell the first string is greater and the second string is smaller. Why? Because the first string B is greater and A is smaller. So, and the same thing exactly comparative function does. It compares two strings alphabet by alphabet until it finds the first non-matching alphabet. Once it gets that non-matching character, what it does it subtracts the ASCII value of it. Okay. So once it gets the non-matching character, for example, this, it will subtract the ASCII value. So what's the ASCII value of B98? What's the ASCII value of A97? So it is going to give it a positive 1 here. Right. So positive 1 means if any positive number means that the first string is great. Sorry, that means the first string is greater than the second string. What does a negative number means? If you get a, let's say you have a Z over here. Okay. So now this is basically subtracting 98 minus 122. So you'll get a negative number. So basically in this situation, it is meaning if you get a negative number, that means the second string is greater than the first string. That's why the ASCII difference in the ASCII value is negative. Okay. If the first string was greater, then the difference in ASCII value would be positive. If the second string is greater, difference would be negative, and both of the strings are equal, it gives you 0. Okay. Now so this is the basic simple logic of comparative function. There are few edge cases. For example, like this. So this is one edge case where you get AA and this is AABC. So what does this return in this situation? It will compare first two characters, all of them are equal. So it will give you the return as the length of second string, but as minus. Here it is telling the second string is greater. This is greater because it has two more characters. If you have the first string, let's say this is having A, B, C, X, Y, Z. If this is the scenario, then you would get +3. Why +3? Because the first string, the characters it compared, all of them were equal and it has 3 more characters. So it is telling +3. Okay, so these were the few edge cases in case of compared to how it works. But yeah, this is the general case where if you get a positive number, the first string is greater. If you get a negative number, that means second string is greater. Simple thing that you can take from here. And there was one implementation of comparative function that I wrote. So this was compared to, and then we wrote the implementation of it. Right, it will compare two characters, and if they are not equal, we find out the difference and we are done. If they are equal, right, if we don't get any non-matching character, then we'll check if the lengths are equal. If the lengths are equal, then the difference is 0. If the lengths are not equal, then the difference is n minus n. So that edge case you don't need to remove, right? So edge case is also fine, right? It is giving you the positive negative case is working fine, right? If it is positive, you get the positive. So if the first string is greater, you still get positive. If the second string is greater, you get negative. So that's fine, right? So we just wanted to check if the first string is greater, so we should get positive, and we are getting it. Okay. Clear? So this is what this question was. So I guess this is also done. Now this is interesting one. Next one is very interesting. Achha, I gave a very good amount of time. Given an array of positive numbers and a value k, print the count of subarrays having sum greater than k. How many of you tried this one? So I gave very good amount of time to solve this. So this was easy, right? This was like this is the simplest variation of cadence algorithm that you can get, because here I've told you like the numbers are positive. Okay. So what does positive number mean? See. Okay. So let's say we'll start finding out the sum. Okay. So you can find out the sum. So for int I equals to 0, I is less than n, I plus plus. Let's take any positive array. Okay. Okay. See. So what we want to do is we just take sum is equals to sum plus a of j. Okay. Now let's say you got the sum is greater than 0. What does this mean? If you get the sum is greater than 0, what does this mean? So it's greater than k. इसका मतलब क्या है? You got one sub array that is having sum greater than k. Yes. Okay. Let's say equal to as well, greater than or equal to. यहाँ पे equal भी consider करते हैं. ठीक है. So your subarray is starting from 0 and ending at index whatever is the current index, right? So whatever is the current index, this is a subarray which is having sum greater than k. So let's take some numbers, so that will help you think through this. Let's say int k is equals to 12. Okay. So k is 12, and what we are checking over here. So firstly, see, first iteration will check. Okay, first iteration will check sum is equals to 4. Sum will get added 4 is 4 greater than k. No. Then we'll add 2 to it. So 4 plus 2 it becomes 6 is 6 greater than k. No. Next we add 1, it becomes 7 is 7 greater than k. No. Next we add 5, it becomes 12. Is 12 greater than equals to k? Yes. Now 12 is greater than equals to k and the entire array is positive. What does this mean? Anyone?
Next, all the subarrays are greater than sum.
Yes. Next, sorry, this is not there. This is I. Sorry. All the next subarrays that you will be forming from here, right? So we got the subarray till here. Now you keep on extending this subarrays. All of them are greater than equals to k, because there is no negative number. All the numbers are positive, right? So wherever you are, right now, wherever you are, how are you going to increase the count? Tell me how you are going to increase the count over here. Count is equals to count plus. So let's say you're on I, okay, which is over here. You're on 5, right? So how many more subarrays you can form? This is one subarray, 2, 3, 4, 5, 6, 7. You can form 7 subarrays all together if you keep on just extending. So that is, I guess, n minus I, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. 10, I guess 10, you know. 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are total 10 numbers. We are currently on 0, 1, 2, 3. 10 minus 3, we are going to get 7. But the index is going to be 9 plus 1. I guess this is n minus I plus 1 hoga, I guess. Check for this. Oh, plus 1 minus 1 scenarios is always there, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you do 9 minus 3, which is 6, right? But you get total 7 arrays. This is 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. Right? So it is 9 n minus 6. This is plus 1, right? So 7. It is n minus I plus 1. Okay. Easy to figure out, not difficult. Okay, so always take care of plus 1 minus 1 scenarios, right? That are always there in because of this zero-based indexing. Can't do anything about it. Okay. Now, since we counted this, what's next? So हमने तो सारे subarrays count कर लिए. We counted all the subarrays here and then all the subarrays extending here. Are we done? Can we break the loop? No, what is remaining? Next index. See. So now you you can go to I plus plus, right? How is I plus plus going to change? I plus plus जाएंगे तो फिर हम यही सब एरे मिलेगा, तो इसको तो हमने काउंट कर लिया है. No, we will start from here. No, we'll not start from here. The starting index will change, but where will the starting index go? So we'll start with 2. We'll start with here. See, what we'll simply do is, so let's take a start index. Okay, let's call it a start index, which is at index 0 currently, right? Because we started with index 0. Every time we get this index, what we'll do is we simply do one thing. Sum is equals to sum minus whatever value we have at start index. Okay, and we'll increase start plus plus. Now check. What we are doing is check this. So we are basically doing this. So we started with index 0 and we got this. Okay, ye mila. That's clear. So firstly we got sum. Sum is equals to 4 plus 2 plus 1 plus 5. We got 12. Okay. Once we got 12, we counted all the subarrays, which is count became 7. Okay. All the subarrays like 5, then 7. Then we'll add this. Now what we did was we told, okay, let's remove one number from it. Okay. First time let's subtract this from sum. So 4 ko remove kar dete na. Okay. Now we removed 4, we got 8. And we also increased the start became 1. Now we change the start to 1. Basically, we are considering this subarray. So what is the sum of this subarray? That's 8. Oh, now this subarray sum is 8. Next iteration will go, we'll add 7 to it. So now adding 7 to this becomes 15, which is again greater. Now what we are telling that add any more numbers to it. Now this again became greater. So we'll again satisfy this logic. We'll count all the subarrays, but now starting with 2. So this is the first subarray. Then we'll check this, then we'll check this. All the subarrays will count. Now basically we are counting all the subarrays starting with 2. Okay. Next, since we counted all the subarrays starting with 2, what we'll do is we'll remove 2. So we'll do minus 2, we'll get 13. And then we are considering this subarray and we'll add 1 to it and we'll check if we can make it greater, and we can consider all the subarrays like this. So how many of you understood this and how many of you did it? So I'll explain both this part, this one and this one. No? Yes. So listen to me once more. See, what I'm telling is, okay. See, what I'm telling is, every time we get a sum greater, right? So our numbers are positive. Numbers to positive, right? So that means if you keep on adding any more numbers, your sum is going to become greater and greater and greater, which is going to be greater than k. Right? See, my simple logic I'm telling is, let's say I found this is subarray which is having sum grade 12. Now all the numbers are positive. There is no negative number. So if you keep on adding numbers, your sum is going to become greater and greater and greater. So why do you need to find out those sums and count it? You just count all the subarrays that you can form by adding 1, 1, 1 numbers. Okay. So we can figure out how many subarrays we can form. How can we figure out? So let's say what we did over here, I simply told, let's start from here, right? So this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We took I is equals to 0. First iteration, sum is equals to sum plus a of I, sum plus 4. So sum became 4. Okay. Next iteration, I became 1 and sum was not greater than equals to k, so we do not do anything. Next iteration, we added 2 to the sum became 6. Okay, still not greater than k, so we did not do anything. Next iteration, I became 2. We added 1 to it. Sum became 7. Okay. Okay. Still not greater than k, we did not do anything. Next iteration, I became 3. Sum became 7 plus 5, which is 12. Now the sum became 12. Now this is greater than equals to k. Now this is the subarray which is having sum greater than or equals to k. Now what I am telling here is, since all the numbers are positive, this is the first subarray you got. If you just add one more number, this is also going to be greater than equals to k. If you add one more, this is also going to be greater than equals to k. Add one more, and one more, right? So how many total subarrays you will get? So you'll get 7 subarrays. What are those 7 arrays? Subarrays 4, 2, 1, 5, 4, 2, 1, 5, 7. 421,571. So basically we are adding 1 numbers at the end of this subarray and telling all these subarrays that we are forming is also having some greater than equals to k. So I simply counted all the subarrays. How did I count? So I just figured out, okay, so this index is, if this index is 3, the last index is n minus 1, right? So last index is n minus 1. Okay, it is. Oh, this is index, right? So it will be n minus, okay, sorry, n minus 1. Okay. So the n value is 10, right? Last index is 9, so n value is 10. Sorry, it is n minus I. If we do 10 minus the current index 3, we are getting 7. So this is nothing but all the subarrays that we are forming, right? So it is n minus I. Understood why it is n minus I? Sorry for that confusion. I misunderstood this to be n. Okay. So if you do n minus I, you are going to get that these are the 7 subarrays that you can form. If you have this as the subarray, this is one subarray, and you can keep on adding. These are the remaining elements. You keep on adding to it, you'll form 7 total subarrays. So I just added 7 subarrays to the count instead of forming those subarrays or finding out those sums. Understood this part? Yes, till here. Any doubts, anyone? N minus I? No, sum doesn't need to be reinitialized. See, so I just counted all the subarrays. देखो, एक subarray तो मिल गया. This is the subarray that we got. Understood everyone? ये तो subarray मिला. ठीक है? We got one subarray. Now what I am simply telling is, don't find other subarrays. ठीक है? You add any number to the end of it which is positive, the sum is going to be greater than k. Acha, tell me if you add any more numbers to the end of this which is positive, 1 number, 2 number, 5 numbers, 10 numbers, is the subarray going to be sum is going to be greater than k? Yes or no? If you add any numbers to the end of it, is the subarray sum, the new sum that you get, it is going to be greater than k. I've given you the constraint that the numbers are positive. Agar number negative hota, then only the sum will decrease. The numbers are positive, so sum will keep on increasing, and we are just have to check for greater. So we don't have any clause, right? Ki sum can decrease, sum will increase. If you create this subarray, sum is increasing. If you create this one, sum is increasing. This one, sum is increasing. So sum keeps on increasing, and your sum is going to be greater. Okay. Okay. First thing. Now what's next? So how many subarrays we can form in total? Kitne subarrays form honge? So if this is the subarray, you add 1 number, you get 1 more subarray, which is 2 subarrays. You add 1 more number, you get the 3rd subarray. If you add 1 more number, you get the 4th subarray. Add 1 more, get the 5th. Add 1 more, get the 6th. Add 1 more, get the 7th subarray. Right? Acha. ठीक है. See, ठीक है. I guess वहाँ पे confusion है. See, +1 -1 simply I just did ये करना है. देखो कितने subarrays form हो रहे हैं यहाँ पे? 7 subarrays form हो रहे हैं. That everyone agrees. ठीक है. अब will try to figure out कि 7 आ कहाँ से रहा है. 7 subarrays है, right? Looking at this, यहाँ पे 7 है, right? n minus I, n plus I, कुछ भी हो. See, there is, I also don't know कि कितने हैं. What is that number? What is that figure? N minus I, n plus I. I know that these are 7 subarrays looking at this particular example, or if there is any example, it is going to be this, right? Now, what we need to do is we need to find out how is it related to n I or n minus I or whatever it is. कुछ तो relation होगा, right? Yes, it is related. What is that relation? So if this is index is 3 and the n is 10, so 10 minus 3 is equal to 7. So that is the relation. That's it. Right, so that many numbers you can add in between. So that's 7. There are 7 numbers from here: 1, 2, 3, 4, 5, 6, 7. So that is the total subarrays. Or you can do 9 minus 3 plus 1, which is also 7. So this is basically n minus 1 minus 3 plus 1. So it is n minus 1 minus 2, which is n minus, sorry. Okay. This is the current I, sorry, this is I, right? Why we are taking this as okay. If you take it in this way also, yes, let me just clear this out. So either you can take it is 10 minus 3, which is n minus I is equal to 7, or you can take it in this way. This is 9 minus 3, right? Or you can take it as 9 minus 3 plus 1 is equal to 7, or 9 is n minus 1 minus I plus 1 is equal to 7. In this situation also you're going to get n minus 1 minus I plus 1, which is n minus I is equal to 7. Understood? ये तो बस नॉर्मल डिडक्शन है ना, इससे तो रिड्यूस करा है ना, बस n माइनस आई करा है उससे, और कुछ तो नहीं करा, राइट? बस रिलेशन फिगर आउट कर लिया, ठीक है। अच्छा, अब चलो ये पता चल गया, वी गॉट दिस, सो वी काउंटेड ऑल द सब एरेज. So is this it? Can we get any more sub arrays? Yes, we can get more sub arrays. How can we get more sub arrays? See, so we got all the sub arrays that is starting at index start. Okay, we had not moved the start index. Start index was fixed, which was 0. Now, if we start moving the start index, we might get more sub arrays. Okay, so let me clear out everything. So this is the current sub array that we are standing on, which is having sum 12. We found all the sub arrays that we can form by adding more numbers to it. That will be greater. So we counted them as well. वो directly count करते हैं. We didn't even found the sum. We didn't even form those sub arrays. कुछ करा ही नहीं उसके लिए. ठीक है. Next, what I am telling is कि what we will do, we'll move the start. So how we are going to move the start? We'll just remove one number from start and make the sub array this. So how is it going to impact? We don't have any thing storing the sub array. We'll just reduce the sum. So just reduce the sum with the start index, which is this 4. Sum becomes 8. So that means this is now the new sub array. Sum is storing the sub array, right? So this is the new sub array. And we move the start to start plus 1. The start becomes 1. Now this is the new sub array, which is 8. So, okay, fine. This sum is, okay. There can be only one scenario. If this was 0, right? If this is 0, so this can also result in a sub array sum equals to k, right? So that is the scenario that we can consider to increase. If this sum that we got new is equals to or is it if it is greater than equals to k, then we can increase the count as well. Okay, so this is one edge case that was remaining over here. So for example, consider starting index में 0 होता. So we remove this minus 0. जो भी sum था which was becoming greater than k, so it would still remain greater than k, right? So for example, take this example. So यहाँ पे क्या sum आएगा c? So you'll get the first sum that you'll get is 0. Then you'll add 2 to it, it becomes 2. Then you add 1 to it, it becomes 3. Then you add 5 to it, it becomes 8. Then you add 7 to it, it becomes 7 plus 5, 8, 50. Which is greater than k, so you count the, so this is your first sub array, you count all the sub arrays after it, n minus I करके you counted it. Now when you reduce the first start, you get this sub array, and you basically need to check whether it is equals to count or not. If this sub array is equals to count, yes, sorry, someone is saying something. Achha, if this is equals to count, then basically, okay, this will then might look like. If you have any questions, remove it. Zero के लिए it becomes problematic, right? This problem is okay. Let's stick to here 1 second. Like I guess now 0 में there will be a lot of edge case if we are having zeros at the start, right? So there might be edge case. I'll talk about zeros. Like let's just complete this discussion without zeros once. Okay, there might be a lot of edge case that might be flowing for zeros. Okay, we'll discuss them separately. Let's complete this one. Okay, so we got this. Now we just increase the start, right? So sum mil gaya, right? We got this sum which is 12. So we reduced it. So 12, then we reduced 4. Minus 4, it became 8. Okay, we increased the start. Start came over here. Okay, start came over here, and this is now the new sub array. So this sum is going to be less than that, right? Assuming that this is not 0, the sum is going to be less than that. So we are going to start again by adding a new number and checking if this sum becomes greater. So we add 7, it becomes 15. Yes, the new sum is again greater. We increase the count again, and then we remove 2. So we remove 2, it becomes 13. So we get this, which is 13, right? Now, okay. Now this would be a valid check to check if this sum is greater. Right? If this sum is greater over here, then we can consider all the sub arrays starting from this. By removing that number, if we get the sum is greater, we can consider all sub arrays. Why loop में डालते हैं? Remove it. Remove all the sub arrays. Remove it. Get all the sub arrays. Okay. Okay. So I guess now we'll need to do this in a while loop, right? We just need to do it in a while loop while the sum is greater. We'll need to keep on running, doing this operation. Okay, so we'll get all the sub arrays and minus I, and we can increase. current value, and we need to check until the start is less than, the start is less than equals to 5. Okay, I guess this is fine. So if we do this, it will also cover the zero wala case. See, so what we have done over here is, I'll just recap of what I did. So there was one case that was, so let me explain using this, you'll be able to understand. So first we got 12. Okay, so this is 12. Okay. Now what I told, right, we simply added the count, we just added the count, we checked, we then decreased it by 4. So we decreased it by 4 and it became 8. And we just increased the start by 1. Start became 1. Okay. Now we check this start less than I. Yes, start is less than I is equals to I is sitting at index 1, 2, 3. I is sitting at index 3, or start is sitting at index 1. It is fine. Is the sum greater than equals to k? No, sum is not greater than equals to k. Sum has become less than. We don't run it again. We just go to the next iteration where we add the sum. Sum becomes 15. Now check. Now just look at this iteration carefully. Now what is our subarray that we are currently considering? So this is the subarray that we are currently considering from 2 to 7. Okay. Now here what we are doing is, when we got this subarray start less than I, yes it is. Is sum greater than equals to k? Yes, sum is greater than equals to k. So what we need to do over here is, we'll count. We'll increase the count. So how many subarrays we'll get? Keeping this, so we'll get 2157, we'll get 21571, 215714, right? All these subarrays 2157149. So same logic we just did, n minus I. So this is whatever is this index, that is I. We have n, so n minus I. This is the total number of subarrays we can form. So we simply counted them. ठीक है, हमने count कर लिया. Okay. ठीक है. So we counted them. Next what? So since we counted
Sir,
them,
while loop का condition थोड़ा सा समझ नहीं आया.
ठीक है. So while loop condition is, so this is like the normal जो if में लिखा था, right? Sum is greater than k, will count. Why I have written it start, I'll explain that. See. So now once we counted this part, right? यहाँ से जितने subarrays होंगे we counted it. Understood? This one we counted all the subarrays over here. Now what we are doing is, we are removing one number from start. So we remove 2 this time. Now this is 13. Now tell me one thing. After removing one number from the start like this, in this current scenario, the sum is still greater than k. Yes, sum is still greater than k. Can this be a subarray? So for example, can this be a subarray after removing this, which is greater than k? This is a valid subarray which is greater than k. If I just run the for loop, what would happen is, we'll add one more number to the end of it. This is a valid subarray. We'll end up making this subarray like this. Okay. So we should not do this. We should actually count all the subarrays that we can form from here. So what are those subarrays that we can form from here? The subarrays that we can form from here is, we can simply count them. So we again enter the while loop, since the sum is greater than k and this start is less than I, we again enter this. We count all the subarrays. So now I is still over here, and we count how many subarrays we can form from here to here. So that is again n minus I. So now we are counting this subarrays 157, 15711, 15714. Understood this? I'll come to zero wala case. Just understand this one. Okay, got this? Okay. Next, so since we counted all the subarrays starting from here, we can again remove the start. ठीक है, हमने जो सारे subarrays count कर लिए, that is starting from 157. So we'll remove the start. We'll again decrease it by 1. It is again 12. Oh, now this subarray is again greater. So if I even move the start to here 57, it is still greater. Start is less than I. Yes, that is fine. Start is over here. I is over here. Sum is still greater than k. So if I take this subarray 57 and I have keep on adding more number 571, 571 for all this subarrays, this is still greater than k. So we'll again count them and we'll again remove 5 from here. Okay. Achha, let me print all these subarrays and show it to you. So what are the subarrays that we are considering, right? So let me just print system.out.println. Let me just print the start index and end index. Your start is going to be start. Your end index is going to be I, which we are going to get is greater than this. If start plus plus is outside, it will not become outside. It will become greater than I. So that iteration we are terminating, right? As it becomes greater than I, we terminate. Next, like after this while loop is done, I increases. So start and I again become equal. So it is similar to having the sum as 0. So basically we will be starting with here, and it would be in the scenario like if this number is value is equal to 12. So we'll get this start. So if we have a single size array, so this is also valid subarray, which is having the like k value greater than equals to k. We keep on adding it, so this becomes greater than equals to k. Now we just remove this as well. So our sum becomes 0 and our start comes over here. Next iteration we increase I also comes over here. Okay. See, so these are all the subarrays. See, so there is no overlap. So firstly, we are getting 0, 3. So this is the subarray, which is so let me write all the subarrays. So 0, 3 is this subarray. So 4, 2, 5. Okay, let me write clearly a little bit. Let's take red. Let's take the color. So this is 4, 2, 1, 5. This one is 1 to 4, which is this. Okay, let me run it. I guess 7 clear run kara tha humne. Okay, so 4, 2, 1, 5. This is 2, 1, 5, 12. This is 1, 5, 12. This is 5, 12. This is 12, and this is then you get 5 to 7. 0, 1, 2, 3, 4. This is 5, 6, 7. So 1, 4, 9. Then you get 6, 7, 4, 9. Then you get 7, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, 1, 2. So these are all the subarrays that you'll get, right? And any character that is added to the end of it, like any larger subarrays apart from this. So these are not only the subarrays, like 4, 1, 2, 5. When you add any character to the end of it, any numbers to the end of it, like 12, 1, so all of them form the subarrays, which is having greater than k. थोड़ा सा आइडिया लगा what we did over here? नहीं, ये वाला नहीं चमका कि क्या करा हमने while loop में. देखो, while loop में we noticed one thing, that when we are removing character from the start, we might still have a subarray which is greater than k. Start से एक number remove करने से subarray sum less than k नहीं हो जाएगा. Right? It may be still greater than k, and in that situation हमें क्या करना है ना, उस subarray को भी consider करके same logic run करना है. So हमने क्या करा, अगर एक number remove करा है और start को आगे बढ़ा दिया, ठीक है, and we have run it in a loop. So हम फिर से check करें, start less than I, yes, start less than I है, मतलब हमारा sum greater than 0 है. ठीक है, अगर स्टार्ट लेस देन आई है मतलब सम ग्रेटर देन 0, एटलीस्ट एक नंबर तो हमने कंसिडर कर रखा है. स्टार्ट टू आई हमारा सबैरे दैट वी आर कंसिडरिंग. सो इफ स्टार्ट इज लेस देन इक्वल टू आई, वी हैव एटलीस्ट वन नंबर. अगर इक्वल भी है तो वी हैव एटलीस्ट वन नंबर. इफ सम इज ग्रेटर देन के, then what we are doing is we are checking if we add any number to the end of it, we will basically increase the will basically have a subarray which is greater than k. ठीक है, sum is greater than k. Now we again remove the sum, one number from the start, we increase the start, and we check are we still having a sum greater than k? If yes, then we count it. Okay, and at the end we can print the count. So this is the count. Okay, now can you figure out the complexity of this? And I can give you a hint, it is not n square. It is total 38 subarrays that we have that we can form, which is having this. Do you want to see all the 38 subarrays? So let me run this loop from start to end. Let's go this one. Sorry, how can I run it for I? This is going to be starting with start, ending with. अच्छा कितने सबैरेज होंगे, ये तो n minus I होगा ना. Okay. This is going to end at I plus. Okay, 0 I plus 1 minus 2, ठीक है, less than I. Next to allow the bounds. minus I star gets less than I. So worst case n minus I plus n minus I minus 1, n minus I minus 1 plus I. So it is n minus 1 तक ही जाएगा, right? Just a second. R is less than G. So start 2i plus 1, I plus 2i plus 3 to n minus I minus 1, n minus I minus 1. So n minus 1 तक ही तो जा रहा है. That should be fine. Have I changed some? Oh, I am printing K. So this is, oh, sorry. Sorry. ये क्या हो गया? See, so these are all the subarrays. See, so firstly we got this subarray, and we kept on. We did not find all these subarray. We just counted them. ठीक है, अब हमने print करा. We did not find these subarrays. Actually, we counted them. Next we got this subarray, and we just counted all these subarrays. We did not find all the. We did not like basically find these subarrays or their sum. Next we found this subarray. We did not find all these. We just added all these subarrays count. Okay. Next we found this subarray. We did not find all these subarrays. We just added its count. Next we just found 12, a single size subarray. We just added all its count. We did not find this subarray. Okay. Finally we found this subarray. We just again added it in the same way. We did not find all the subarrays and did this again, right? And finally we got the count is 38. You will see there is no duplicate subarray that we counted. There is no such duplicate over here. Every subarray is unique. And we have counted all the subarrays that can have all this sum. Okay. And you know the best part of this logic, if you don't have to print this subarrays, what's the complexity of this logic? It's not n square root of n. It is
order n.
This is the order n logic. Why O of n? So let's figure out why this is the order n logic. See, so this is
only I increase, sir.
So this is I increasing, and this while loop is running, but this while loop also will go only one iteration, one single traversal. Where, see, start, we have while loop is running for the start value, right? Start is increasing from 0 and start is going till where? N, right? So basically, if you combine all the iterations of the while loop, it is doing a single traversal of array. If you combine all the iteration of while loop, it is doing a single traversal of array, which is order n. If you combine, this is the order n traversal. So I is moving from n, start is moving to L, but this is for every I value, it is not going for n. For the entire I values combined, for I equals to 0, 1, 2, 3, 4, all the values combined, start is moving till n. So basically you can think like one pointer start moved from, I moved from 0 to n and start moved from 0 to n. So we did a single traversal. Basically, you can tell it as 2n. The number of traversal required, but it is O of n, complexity wise. So this is the order n logic. We counted all the subarray sums which are greater than k. See, so good, right? So good logic. हाँ, print करना ही नहीं है ना. Print you will never ask to get. You will be never asked to print. अगर if you are asked, let's say to print, are you required to print over here? No, you are actually not. Why will you print over here, right? You can simply store the start and end index, and you can print it later, right? Print तो करना ही नहीं है. See, if the printing is asked, printing is different, right? Print करना है, that's a different. Most of the time, the questions will never ask you to print these things. It will just ask you to count, because this is where the optimization is, right? If I ask you just to count, any name given to this, so this is like a modified cadence algorithm, right? Same cadence में हमने जो logic use करा था, we use the same logic over here. If we did the same thing, we are trying to find out the subarray sum. If the sum exceeds the value, what we do is we try to count the subarray. Now the count logic is different. There what we were doing is the subarray sum exceeds, but like if the subarray sum becomes negative, we start a new subarray. Right? वैसे ही कुछ कर रहे थे. So if the subarray sum becomes greater, we count all the subarray and then we start a new subarray. It will not work for negative number. That's why I explicitly mentioned that this numbers has to be positive. It will not work for negative numbers. Agar negative number hai, then what is the problem? That means, for example, you got this subarray is greater than k, equals to k. Now you don't know whether adding the next number will make the sum greater, less than, or what it will become. Right? We may or may not move ahead. Did not get the complexity? See, in simple words, I can put the complexity is all the operations of while loop combined is order है. सारे I के iterations में while के iterations को combine करो. If you combine all the iteration of while loop in the I, combined all I equals to 0, 1, 2, 3, it is order n. This is going to run for at max n times. Why? Because at every iteration start is increasing and start will when if start reaches n, right? So that will terminate. So this is all the iterations combined order n. ऐसा नहीं है if for every I value it is running for order n. For all the I values combined it is order n. So you can say it is 2n iterations on the array, which is again on. It's not n into n, it is n plus n. Yes. Right, modified guidance. So I'll write it as, let me write it over here. I gave you hint modified cadence. So these are the kind of variations of cadence that you can expect in interviews or something where you will require little bit advanced coding, right? Thoda sa advanced test kar rahe ho, so these kinds of variation it will ask. It will not ask you directly. Cadence directly askal thoda sa you might not see because that is something which everyone knows. So is tarike chote mote variations honge. Okay, not very difficult to figure out, but thoda sa tricky hoga to think it. Okay, you might not even get the see. I also made a mistake, right? I took it as if condition, then I realized while running it, we might need a while, not a if condition. While loop will only go to like for a single traversal. एक single traversal ही करेगा, combined सारे I के iterations के लिए order n तक ही जाएगा ये. ठीक है? It is like order n for all the I iterations combined. क्योंकि start I तक जाएगा, it will stop. Then it will I will increase, then start will increase. Then I start will reach till I and then it will stop. Right? So it is not going for entire traversal and not repeating. Right? Start पीछे से भी start नहीं हो. Start is not starting from zero every time. Starting just from wherever it is just starting to move forward. Okay, understood? Now go through this logic. This is like again very interesting. So this logic is very interesting. The logic that I shared over here is Pangram 1. This is very interesting. Then this is very, very good time optimizations that you will gradually learn over the course of time. You'll make a mistake. There is no YouTube videos or tutorials that you'll find out for such questions, right? So you need to, you will ultimately make mistakes, learn it yourself. So I'm just trying to show you how variations will be there. Now there is tons of other variations that you might get. So for example, what will you do if there are negative numbers, right? What will you do if you have to basically count the subarrays which have some less than, not greater than. Less than is again, less than may negative के लिए भी then it can be a negative numbers. Sort नहीं कर सकते, right? Sort कर ही नहीं सकते. If you sort it, you lose the entire subarray context. Subarray has to be continuous, right? अगर हम इसे sort कर देंगे, then it will become so you will lose the entire subarrays. तो subarray तो हो ही नहीं सकता फिर वो, right? So in case of questions like subarray, subsequence, you cannot sort the array. Sorting is not even an option there. So you have to figure out something without sorting. Okay. So it might also happen ki, let's say in the next number is negative, which is decreasing the sum. But if you take two numbers, so the next number might be negative, but then just the next number to it can be very large positive number. So this can be a valid subarray. So you don't know how many subarrays you'll form. So you'll need to keep on adding numbers, and that is again a little bit tricky. So negative numbers, you can think of it. It is going to be a little bit challenging than this one. Okay. So I'll give you dinner break. Go have your dinner. We'll come back and we'll discuss few more questions. You all have shared a few questions as well, so that also we'll discuss. Okay. Quickly come back. Have your dinner. Yes. Hello, everyone. Welcome back. Sorry, yeah. So I think we can start. Okay, so what's next, right? So I discussed all the questions that were there. Now, firstly, tell me, do you have any doubts remaining from the portal? एक spiral order traversal रह गया था. Apart from that, any other question that's remaining? चलो इसको कर लेते हैं discuss. ठीक है, let's discuss this one. I have to like, चलो I'll even show you a few things on spiral order. Okay, for those who have done this, so it might be interesting for you all as well. Okay. So see what is spiral order traversal, right? So we want to traverse the matrix, but not in the normal order, but in the spiral order, right? So what does this spiral order mean? So let's say we are given a matrix. So what we are telling is we'll traverse this matrix in such a fashion. Like we'll start by traversing the first row, then the last column, then the last row, then the first column. Now the order of printing these elements is also very different, right? So firstly we print this one, then we print this one, then we print this one, and then we print the first column bottom to top. Okay, so let's take a two-dimensional matrix, something like this, and A is equals to let's take 1, 2, 3, 4. Okay, so let's say this is the matrix that we want to print in the spiral order. And let's do this. This looks good. Okay. So this is the matrix that we want to print in the spiral order. Okay. Let's find out the size of this one. So we can do n is equals to a dot length. We'll get the length of this one. And we'll do int m is equals to a of 0 dot length. We got n and m, right? We got the number of rows and the number of columns of this matrix. Now what we can do is we can start with a particular row that we want to print, right? So what's the first row that we want to print is 0. Okay. So row 0 signifies the row that is like the start row. Column signifies the start column, right? So we start with column 0. So we are starting with row 0. Our last row is n or n minus 1, right? We can take it. So let's take it equals to n. If you take it minus 1, so it will be equals to n. If you take it n or m, it will be less than that. Okay. So we have taken it minus 1. That means this is the index and m is the index, right? So this is the index of the last row and the first row. Okay. Just a second. Shall we take it minus? Chalo, let's take it n and m. ठीक है, less than consider कर लेंगे, right? Makes it easier little bit to at least think. Okay. Till when we want to print? Until the row index that we have, until the row index is less than the row, and until the column index that we have taken is less than the number of columns. If this is the condition, then we have rows or we have columns and we want to print this matrix. If this is not the condition, then we don't want it. Okay. Now in the first iteration, where should we start? We should start by printing the first row. That is this 1, 2, 3, 4. How do we print the first row? So first row, we know that if you want to print any row, right? So what we can do is we can start with the index, like we can start with the starting column index and we can go till the ending column index. Okay, that is m. Okay, I plus plus. So row index is fixed. What is this row that we want to print? So the row that we want to print is the index row. So we can print system dot out dot print, and we can print a of the row index is row and the column index is I. Tell me how many of you understood this? Doubts on this one? So basically we fixed the row index. The row index is row and the column index is varying from column to M. So we printed this particular first row. Understood this? Anyone having doubts here? Clear? Doubts? No doubts? Okay. Now, once we printed the first row, what we can do is we can increase the row. So what I told you you can print the outermost boundary and you can keep on shrinking the size. So increase the row, that will shrink the size. Okay. Next, once we move to the next row, then we'll first printed the first row, then we'll print the last column, which is 4, 8, 1. So this we have already printed 4 till 4 we have already printed. So we have to print 8 and 1, just 8 and 1. So row index is increased, right? So if I just start by running the loop from value row and we'll run this till the last row, that is it. So we are changing the row index and we just fix the column index. So now we have to print a particular column. So what is that column index? So the column index is okay. So it is the last column, right? So last column is M-1. And what is the row index? Row index is this J that we found. Or let's take it I for simplicity, it is easy. I. So see what we are doing over here is we have fixed the column index that is M-1. Okay, now and we are varying the row index from row to N. So we are starting from row. So row has already increased by 1 after printing the first row. So we are over here. So now we'll print this 8 and 1. After we are done with this, now since we printed the last column, we have to decrease the column index. So we can decrease M. Now M got decreased, right? The columns got decreased. Now this is like our matrix. So, like you can see, think this is our matrix. It doesn't include the last column or the first row. It is just these 6 values: 6, 5, 5, 6, 7, and 3, 5, 7. Okay. Now we have to print the last row. So the last row has to be printed in the reverse order. So we'll start with column, last column, which is M-1. The index is M-1. We'll go all the way till the first column, that is col, and we'll decrease I. Okay. And what's the values that we want to print? We are fixing the row index, which is N-1, the last row, and we are varying the column index, which is I. So we are fixing the row index, varying the column index. So once we printed the last row, we can decrease the row index. We can decrease it by 1 and minus. And finally, for the last iteration, we want to print the first column. The first column is starting again from last row. So that is N-1. We are going all the way till the index row and we are decreasing it again by 1. We can do system.out.println print A of the last first column index is so this row index is varying as I and the column index is fixed as column. After we are done with this, we can increase the column because we have printed the first column as well. Okay. Now if I run this, there is only one edge case. I'll talk about that and that might. Okay. So see, we are getting 1, 2, 3, 4, which is fine. Then we are getting 8, 1, which is fine. Then we are getting 7, 5, 7, 5, 3, which is fine. Then we are getting 5, which is fine. And then finally we are getting 6, 7, which is fine. But we are getting one more 6. Now, why is this one more 6 coming? Why is this 6 at the end? Till here it is fine, right? Till here it is a spiral order traversal. If you look at this, it is showing this. So firstly, you're printing this row. Then it is printing this column. Then it is printing this row. Then it is printing this column. And then we are again starting with this. We are printing this. And it should be done over here, right? So this is the correct thing. This is the correct solution. So why is it printing this again? Anyone figured out ये क्यों हो रहा है? अच्छा, how many of you did it this way? ये हो गया था. So now in case of a single size row or column matrix, right? Of one row or one column, what is going to happen is, see, in case of one row, what we do is we'll print this row. Okay, we'll print this row. Row index will increase. We don't have anything to print in the last column. Okay, we don't have anything to okay, but in the last row we again have this row is the last row as well. So we'll print the last row, right? So we'll print the last row. So we'll print this 6, which is again problem. So we don't have to print this again. So what we have to do, what we need to check before printing, right? So in this situation, we have to check. Just a second. So before printing this, so I'll check with a row, right? So I'll check row is less than n. Row should be less than n before printing this, right? Because in this iteration we are printing this one. We can move this. Yeah. So before printing this row, that will check that row is less than n. If this is the situation, then only will print. If it is equal to n, right? Then will not print, right? And same goes over here. We'll check if the column is less than m, then we'll print this. Otherwise, we will not print this. Now, if I run this, see, we don't have that extra 6 over here. See, now how did it get removed? So firstly, we printed this first row, okay, which is fine. This is printing the first row. Now, when we print the last column, we don't get any values because the row has increased. So there is no value after this row in the column. Now we are checking is the row less than n. No, the row has increased, row has become equals to n. So it is not less than n. So this there is no values to print. Earlier, what was happening, since we are not checking this, we are directly printing. So we are printing the last row. The current row is the first and the last row as well. So we are printing this row as the last row as well. Okay. So yes. So either you can take the count wala approach, or you can do if you take count approach, this is like how is it applicable for higher order matrix? What do you mean by higher order matrix? I forgot that term. Kya hota tha ye? Remind me. Is it a matrix inside another matrix or something like that? Aisa kuch tha. More rows and more columns. So more rows and more columns. Okay. So basically a large matrix, right? It would be applicable, right? So we will be just traversing one row, one column, and then we are decreasing it, right? So it doesn't matter, right? What is the number of sections? Okay. Asha, tell me how many of you understood this without these two if condition? Without these two if conditions, samajh aa gaya tha ki what we are doing. Or anyone has doubts in that part? First row, increase the row. Last column, decrease the column. Last row, decrease the row. First column and increase the column. Okay. So if this is fine. So what we are doing is, forget about everything. Take it, chalo, isko bhul jao. Let's take a single size array. This is a valid 2-dimensional matrix. If I run it, this is the output we should see. But if I don't have these checks, chalo, ye if checks ko na 1 second ke liye, let's remove this. So what is going to happen? And let me run this. See. So you are seeing 1, 2, 3, 4 and 3, 2, 1. Now, why is this happening? Let's do a dry run. Take isko dry run karte hain. So row is 0, column is 0. Okay. We start with this. We print from column to 0 to m, right? So 0 to m, we print all the values 1, 2, 3, 4. All the values are in the first row. So we print this. Okay. Now we increase the row. So row becomes 1. Okay. We check here row to n. So from 1 to 1 less than n. So what is n? N is 1, column is 4, right? So 1 less than 1, is this condition true? No, this is false. So this, we don't have anything to print in this last column. So we don't print anything. That's fine. But now here, look what is happening. So we decreased m, right? After this iteration, we decreased m became 3. The column is here, right? So m decreased to 3. Now see what we are doing. Now in this iteration, this loop is running. M minus 1 is 3. So 3 minus 1 is 2. Is 2 greater than equals to the column index? Column, which is 0. Yes, 2 is greater than equals to 0. We run this loop, and what we are doing is we are printing n minus 1. What is n minus 1? So n minus 1 is 0. We are printing the values in the 0th row. So we are printing a of 0 and I. What is I? 2. So a of 0, 2. What is this value? 3. So we print 3. Then we print a of 0, 1, which is 2. and then we print A of 0, 0, which is 1. Now we printed actually this thinking this is the last row. This loop was supposed to print the last row, and we ended up printing the same row that we printed as the first row for a one size for a single size row, for a single row. So how did I avoid this? If condition, how is this checking? How will this check avoid that this row is not getting printed twice? So see, what is this if check doing? So I am checking, is the row less than n? That means this is the current row index is not equals to n. That means the row that I am considering is not the last row. So basically the first row and the last row is not matching. So for example, here, now what is going to happen? We are still having all these values are same. Now putting this check, what it is going to do, we are checking what's the row index. Row index is 1. Is 1 less than 1? No, this is false. So we will not print the last row. It means if the row is equals to n, that means the first row and the last row is same. If the row is less than n, that means first row and last row are not same. If there are multiple rows, then the first row and last row is not same. In that situation, we'll print the first row, when the last column, and then we print this. But if there is only one row, the first row and last row index will become same after doing row plus plus. Understood? So row was 0 and n was 1. If we did row plus plus, it will become 1. That means first and last row are same. So we don't need to print the last row since we have already printed the first row. And that is same. So in the cyclic order traversal, this is it, right? We don't do this, right? Understood? Now is it clear? And same thing it is applies for a single column matrix. So that's why this check is there if the matrix is of a single column. Now initially it might not be a single column, but what would happen is eventually when you do this, okay, let's take a large matrix in case you all are very interested to take a let me copy this. Okay, let's run this. So this is the row and column order traversal. Well, let's validate. So we are getting 1, 2, 3, 4. Fine, 1, 2, 3, 4. 8, 1, 4, 1. So 8, 1, 4, 8, 1. Okay. 7, 5, 3, 7, 5, 3. 5, 1, 3, 5. 5, 1, 3, 5. Then we see 8, 7. Sorry, 6, 7. Last column 7, 3, 7. 7, 3, 7. 6. Okay, we get 6. We get 2, 5. 2, 5. Okay. Now, no matter how large matrix you take, it is going to be correct, right? It's going to be correct. There was only one scenario that I told you was edge case, which was a single row, single column matrix that you have to take care of. And this is the easiest way to handle it. There is like another way to count it and then take care of it. But I was there edge cases that fail, right? So I find this is the very easy one. Okay. Understood? Clear? Yes and no. My code is like Greek somewhat. Take care. This looks clean, right? This is clean. This is easy to understand. If you understand this condition, it is very easy. Yes, Rajiv, that's the correct one. Vertical order where the column less than. Yes, so that would work if you have a single column matrix, right? So if you have one column matrix, right? So that in that case, vertical order matrix, it will work. Okay. Okay, so finally a spiral order also done. There was one more spiral order 2 question. I guess one test case problem in the question. Otherwise, logic is just to print it in the reverse order, right? There is nothing different, right? You just have to print it starting from here, ऐसा कुछ करना है, right? And then do this. Special matrix. Special matrix where it was, it is 2D arrays में, 2D arrays 2 में. Special matrix I remember हमने करा है, or we have not solved. Square matrix is called a special matrix of all the diagonal elements are 0 and the diagonal elements on the non-diagonal elements of the matrix are 0 and diagonal elements are non-zero. अरे ये तो बहुत easy है. there is you just have to validate these two diagonal elements are non-zero and all the other elements should be zero. Diagonal में zero नहीं होना चाहिए. It is telling diagonal will be non-diagonal element in matrix will be zero and diagonal will be non-zero. Right? Diagonal non-zero होगा और non-diagonal zero होगा. So, like it's a simple logic. Let's complete it, right? It won't take a second, take a minute to write this logic I plus plus. So it is given even a square matrix, है ना, n cross n. If I is equals to j, that means this is the one diagonal. Or and a of ij is double equals to 0. That means the diagonal element is 0. In this situation, we can return false. The second diagonal, else if this is not true, I plus j is double equals to n minus 1. If this is the situation and a of ij is equals to 0, the second diagonal, if the other diagonal has 0, then we return false. Else, if the element doesn't lie in any one of the diagonals and the element is not equal to 0. If the non-diagonal elements are not 0, then we return false. If none of these return false and we finally end the loop, at the end we return true. Okay. Compilation error आ गया. अब क्या प्रॉब्लम है? We got wrong answer. We're getting false. It should be true. Two false are right. If I equals to j, that means this is on diagonal, and this is equals to 0. That means we return false. If this is equals to I plus j is equals to n minus 1. So in this diagonal, right? 0 plus 0. And 2, yes. So this sum will be equals to n minus 1. And if ij is equals to 0, that means we return false. Finally, if this is not on diagonal and a of ij is not equals to 0, we return false. At the end, if this none of them return false, we return true. Should be fine. क्या problem है कुछ? क्या मैंने? It is always square, right? We'll check 0 0. It is 0. I is equal to j, is it equal to 0? No. 0 1. I not equal to j. 0 1 I plus j is not equal to n minus 1. So we check, is it not equal to 0? Yes. No, this is equal to 0. We check for this one. I plus j equals to n minus 1. Is it equal to 0? No. So this is a test case that I'm checking, right? It is returning false. No, I don't know क्या return. So क्या problem है? चलिए. Yeah, I do not get X type. What is that? Zero zero. So 0 0 is this cell. I equals to j and a of ij equals to 0. No, this is false. और यहाँ पे ये कैसे false है 0 0. क्या mistake है? What am I not understanding over here? 0 0 ij is 0 0. We are entering into this. How is this satisfying? A of 0 0 is 1. A of 0 0's value is 0. If it is equal to 0, we should enter. If it is not equal to 0, we should not enter. कैसे possible है? Oh, this is not happening. Ninth line. I guess वहाँ हम एंटर ही नहीं करिए कहीं और से रिटर्न आ रहा है 0 0 1 and we are returning false. Must 0 0 we are checking this first, right? So I plus j. अच्छा ये यहाँ से रिटर्न नहीं हो रहा है एक सेकंड. This is not returning from here. Let me validate. ये कहीं और से रिटर्न हो रहा है. Line number 17. So 17 should not go there, right? We हाँ see 0 0 1 वो वहाँ पे. How is it going to the else part? ये क्या स्ट्रीम चल रहा है यहाँ पे? What am I missing over here? Oh, got it. Yeah, sorry, my bad. So if this is false, we should add the condition I. If this is equal to the diagonal, oh, okay, got it. I guess I have written the if else condition in the wrong way. So see what is happening is basically this is condition is not satisfying, and this should only happen if I equals to j or I plus j is no I plus j double equals to n minus 1. If any one of them is true, so we'll basically take a note of this. Now if I run this, fine. Okay, so basically we did not check for non-diagonal. Okay, that was the problem, right? So for diagonals we checked, but it can be non-diagonal के लिए तो check लिखना है ना. Okay, what is the non-diagonal element? So non-diagonal element is the element okay, this one is okay, that's fine, right? I guess how you can check for the diagonals in one case and so now this is working fine. इसको ऐसे चेक कर सकते हैं. ठीक, I'll write it in a better way. So इसको तो लिखना ही है. No, still we'll need to do this. ठीक है, I guess you can write it in some other way, right? If else condition. So basically, what was happening is I'll tell you. So here I equals to j, right? But this was false. This was like this was not equal. This was not equal to 0, which is fine. So this was false. But if condition was false, so when if it's false, we go to the else if wala part. We check this and we'll check this. And here what was happening, since we did not check that this should be a non-diagonal element, we were checking this, which was fine. So it was returning false, which should not be the scenario, right? We should first check whether it is a non-diagonal element, then only we should check the value. So for diagonal elements, we are checking that the value should be 0, right? In both the case of diagonals, and in case of non-diagonals, we are checking that the value should be not equal to 0. If it is like any one of this, then we are returning false, because for diagonals should be non-zero, right? And for non-diagonals, it should be 0, right? So it is just the reverse. So if it is there, then we return false, otherwise we return true. Okay. Let's check the another ones. I'll quickly go through now the remaining questions, right? So that we can cover the maximum ones. If you have doubts, you can rewatch this part of recording in your own pace. Check if strings are rotations of each other or not. Okay, so I'll put it in this way. So think it in this way. Now this is a very interesting question. Okay, we have done a similar questions like this. Okay, I'll do a quick time and space complexity revision. Okay. Tomorrow is the last. I guess tomorrow we have last session, right? I'm not informed that today is last, so tomorrow should be the last session, ideally. So, did you get any information? When is the last session? Tomorrow. Okay, so tomorrow will cover. Okay, no information. Okay, so I guess tomorrow is the last. Why not till Friday? We'll check. Chalo, might be you might get till 31st, but I doubt that. It might be tomorrow, right? We get at like usually we get 3 revisions. So yeah. One test case is not passing. Chalo, let's discuss this one. So first is like we are given 2 strings of equal length. So we have so the length is equal. Okay, so one case is reduced, right? Take an official. We can take an official one, no issues, right? If you want class, just tell your batch manager, sir, we want more classes, right? We are not done yet. We want more classes. We have time before the module test. We'll take one officially, right? We don't need any unofficial class. If you want class, we'll take it, right? No problem, right? I am available. We'll take it. We'll figure out the time, right? Okay. So what it is telling that we have to check whether P can be converted into Q by cyclically rotating it. Sir, tell me, do you remember one question where we did a cyclic rotation? I remember there was one question on numbers, right? Where we have to do the cyclic rotation for left rotation and right rotation, depending on the K is given as positive or negative, right? Acha. Okay. For this, acha. Now, so let's see what is the cyclic rotation of this going to look like. So, for example, let's say this is the first string and this is the second string. So what we get is BAC, which is this string, and this should be equal to this. Now this should be 10 to the power 5, yes. So this is So we have a very simple n square logic, right? That would work, right? If you figured out, you would get a very simple n square logic. What you have to do is, let's say this is the first string and this is the second string. Yes. Let's discuss out the n square, then we'll think how we can optimize it to order it. So firstly, what we can do is you can compare the first character with the first character. It doesn't match, so you don't need to proceed further. You can stop over here. You can compare this character with this character since it matches, right? This character is matching. So what you can do is you can proceed. You can compare this character with this character, it matches. Okay. You can compare this one with this one, it matches. Now, since you reach the end of this string, what you can do is you can start from the starting of this string. You compare this character with this character and it matches. So basically, this is a cyclic rotation of the first string. So basically, how we started was the logic is simple. Take any string A, B, C, E, F, G. Okay. And the second string is E, F, G, A, B, C, D, E. Okay. Take this one. So now compare this with this, doesn't match. Okay. You just move to the next comparison. You compare B with F, B with E, it doesn't match. So you just move to the next one. You compare C with E, doesn't match. Then you compare D with E, doesn't match, and you then compare E with E, it matches. So once you get a match, you start by comparing the next one, this next, and this next. Okay. And then finally, okay, since it matched it and you reach the end of this string, you start from here. You compare this. Okay, it matches. This also matches. This also matches. Okay, this also matches. If you don't have a E over right? If you have, so this is different. So now this is matching. All the characters are matching. So you can say this is a cyclic rotation. This the hashing is not going to work because this string can be a jumbled combination of this characters as well, right? So for example, let's say count the characters over here. So if you count the characters over here and you count all the characters over here, right? So for example, you got E, A, B, C, F, G, D, right? You count all the characters over here. अच्छा submit हो गया, I guess then it has not वो condition strict नहीं है, right? Because this would also match, but this is not a cyclic rotation of this string, is it? So this is not a cyclic rotation of this string, but if you count the characters over here and you count the characters over here, it will be fine, right? It will tell you all the characters in this string is present in this string as well. Okay. So let's think, right? So what else we can do? So what's the problem with this? This is n square logic. For every character you start with starting and you compare it. So that is the n square logic, right? So how can we reduce it? So now the logic is either you can use KMP or something like Robin Carp. I don't think there is any solution apart from this. We have. Let's think. I don't think there is any other solution we can get apart from this. Substring to find out करेंगे, we can split it. No, you cannot. Can't we keep rotating the string and keep matching it? So see, so if you rotate and match now, that is n square logic. Why? So matching two strings is order n. Okay, if you want to compare two strings, whether they are equal or not, if you use even equals or if you are comparing it character by character, that is order n operation. Okay. Now rotating the string is also order n. You'll do order n rotations. So basically you'll do n rotations and each rotation is order n. Right? So each rotation is order n rotation. You take one character of the start and that is order n rotation. You again check in order n complexity, right? So this is like 2n and then the outer loop is order n. So you get a n square complexity, which is again like the same complexity that we are getting. No, I don't think there is any other solution apart from KMP or OpenCarp. Nothing is going to work over here. You cannot get any other thing working. Sorting also will not. Sorting will basically change the order of characters, which is something you don't want. It is asked, given the constant is 10 to the power 5, you can use n. The only solution that you have is to use order n. Right? Order n square, n root n or n n log and something like that, but you cannot use n square, right? So n square is completely out of the picture. So I guess you only, I think only solution here we are left with is KMP. Now we might need to use KMP. So I cannot explain Robin Carp because for that I need to explain hashing. KMP I can do. So I need some time, right? That will take time. So let's discuss KMP tomorrow. So let me write it over here. As मैंने लिखा था, someone asked. I guess you asked for this question specifically, right? So there is a string algorithm known as KMP algorithm. Okay, everyone today try to look for this. Okay, just try to Google up what is KMP string matching algorithm. Okay, you'll get the idea. If not, we'll discuss it tomorrow. Okay, I'll explain this. Okay, what it is. I don't think there is any other solution apart from using this algorithm to figure this. And I don't know why it is marked as easy then. But I guess it is marked as easy considering the if you know KMP, then this is a easy solution. If you don't know, then this is a difficult. Or even string hashing would work like using Robin Carp. Okay, so you can just search for KMP string matching algorithm. Okay, so this can basically match two strings. So basically, if you are given two strings, marked on April 1. Okay, so let's say this is the two strings, right? So you are given two strings. You have to figure out whether this string, which part of this string equals to this string, right? So you can say that this is found at index 0, right? So now you have to basically do this. You have to find this and order n complexity, right? So how can you find it in order n complexity, not n square? See, n square you can easily find, right? So for example, if I give you two strings and I tell you to find out this, so what you'll do is you'll start by matching first character, second character, third character, fourth character, that is order n. I'll say, okay, it is present or not. Then if the last character doesn't match, then you again start. If let's say this last character is P, So it doesn't match. It matched till third character, but did not match the last character. Then you again start, you match till third character, but did not match the last character. And you keep on doing, you match all the third character, but the last character is not matching. So final complexity you're getting is n square. But using KMP, you will be able to do this as entire logic in order n. So the final complexity that you will get is order n, not n square. Okay. For that, we'll need to use an array known as the suffix array to do this. So I need some time to explain it. It will take a while to grasp this on the first go, but it is easy. Difficult nahi hai. Okay. Okay. So, and this is like a direct interview question asked. I got this question once. So I got this question, and the follow-up question was to implement Robin curve, which is like, which does the same work, but without using additional space, and we use hashing to do the same work. Okay. So this is asked in interviews directly. So I guess ये ना यहाँ पे था नहीं. So I guess it should be there in the like advanced DSA wala part where you will learn about advanced tests. But okay, since we have time, we'll discuss this. Okay. Apart from this, any other questions do you have? Or I guess we have discussed all the other questions, right? This one. So good that you all are trying questions from like Zim, so you'll figure out these questions. Calling out additional bluff too. Okay, there is so many questions. This one, which is this longest mountain subarray. So the mountain subarray basically has a property, it should be increasing and then decreasing, right? So they keep it should be something like that. So length of the subarray should be at least 3. It should have like the first part should be increasing and then the decreasing. It should be evenly split, I guess. So it is very easy, right? Now, this may n is 10 to the power 4, n square will work. So can you not figure it out in n square? N square में figure out नहीं कर सकते. No. Acha, I'll give you one simple hint. Do one thing. So today the palindrome logic that we use, try to use that. So consider every I as center. Okay? Consider 4 as center. Now start moving towards left and towards right. If you get the number smaller towards left and towards right, this is a valid mountain. Okay? Now again add one more number towards left, towards right. Now this is not a valid mountain because 3 is less than 7 and 2 is greater than 1. Okay. Now take 7 as center. Now for 7, try to take this mountain. So this is decreasing, this is also decreasing. Okay, fine. 7 can be the center. Now take this. So this is again 1 is decreasing, 3 is also decreasing. So this can be again the center, right? Now increase its size. No, now this is not following the rule, so it's not a mountain. Got this idea laga ki kya karna hai? How can you get it in n square? The same palindrome wala logic that we use, right? 2 pointers, start from the center, consider everything as center and just to keep on moving. First, you have to not find the center, you just can consider every cell as center. If you consider this center, what is the largest mountain you'll get? If you consider this as center, what is the largest mountain you'll get? If you consider this as center, what's the largest mountain you'll get? Right? And you just have to print the size of it. You don't even have to print that mountain. The size you print karna hai. I told the entire solution, yes. Palindrome wala jo logic tha na, that is same logic over here. So let me take quickly. Okay, now solve this. I'll not close this one so that in case you have doubts tomorrow, we'll solve this one. So this one is the last one I'm taking for today. Is this done Roman number to integer? Yesterday I explained. Ab ho gaya, ye solve ho gaya? No. It's not loading. एक दिन में क्या करे? Yes, time नहीं मिला, ठीक है, चलो take today's time, right? Try to use the time to solve them. Solve it. Why is it not opening? So I have a question and this is not opening for me. So the system is also telling, let's stop over here. Okay, just okay. Tabs. So which question is this? Vishnu, is it open? This one? Calling out additional bluff to this one is the question? Yes, okay. So let's see this one. This is marked as hard, so looks good. Okay, so I'll give you hints till try to figure out. Aryan and Ananya are best friends and they try to fool the other one. Aryan has a evergreen prankster told Ananya that he could do the sum of multiple very large numbers very quickly in order to call out this bluff. And they sat with a calculator, but soon realized that the digital calculator has a limit and can't compute the sum after certain numbers. But she is very smart and converted the large number into a string and wrote the program to calculate the sum and calls out the bluff of Aryan. इसमें string sum करना है, sum of multiple very. Write a program to calculate the sum of large number that are represented. So string को sum out करना है, right? So similar to string, so array sum जो था वही है string के case में करना है. Output is going to be string. Your input is string array of numbers. So found out the character actually. Ajay convert. This is not going to work, right? I guess you did the same mistake, right? यहाँ पे तो यही नहीं करना ना. So this is a problem, right? Remember array addition. What I told you, you cannot convert that array to number, right? Array को number में convert करके add कर सकते. Then why have we stored that number into array, right? यहाँ पे तो clearly mentioned है, right? The numbers are so large that we cannot store it into in calculator. We cannot store it into numbers. So the num that you are calculating, you are basically trying to find out that number that is represented by the string. This won't work, right? This will not work because then let's say the string can be 100 digits. Now the J loop is going to run for 100. Can your number store a 100-digit number? It is a long variable, right? It cannot store a 100-digit number. See, the length size is 500. Your string can be 500 size, right? You don't need to make no big integer can even store. You have to think it in similar way. जो array sum करा था. See, I explained it so much. और you are doing this mistake. Don't do this. See. देखो array sum में why did we sum it, right? Array sum में was there a problem to store this in integer? क्या problem था क्या इसको integer में store करने में? No, we could have converted into integer, right? So यहाँ पे the problem we could have stored it in integer, but if this array size is 100 digits, consider this as number 9 4 2 3 8 1 4 7 5 8. So this number, something like this, very large, something which cannot be even stored in long. Now can you add these two numbers by converting them? Can this number be converted to integer or long? No, it cannot be converted. You cannot convert an array into a big integer even, right? Array can be very large, right? So that's why we did array addition. तभी हमने array में addition figure out करा, right? We added the last digit with the last digit. Only array addition. We did array addition, last digit with the last digit, second with the second last, third with the third last. If one of the array exhausts, we take the remaining digits. Now, same thing you have to do over here, just that you have to do it multiple times. So you have to add these two numbers digit by digit. So you have to take these two strings. You cannot convert these two strings into numbers. वही तो mistake है यहाँ पे. You cannot convert these two strings into number. You have to take the last characters of this, and then so you have to take the last two characters of the string. You have to add them. ठीक है, you have to take the last two characters of this, you add it. You take the last two characters of this, you add it, and then the remaining ones you just add this if you have carry. देखो array में convert कर सकते हैं, that is something I won't recommend. Don't convert it into array because if it is given in string, interviewer won't allow you to convert them into array. ठीक है, so वो array में convert नहीं करने देगा, so interviewer won't allow you. So I told you, right, that same thing that we did on array of array representing each array cell representing digit, we can get the same question with strings, and each string character is representing the digit, right? So now you have to think it in that way. अब उस तरीके से सोचना है, यहाँ पे तो clearly mentioned है, right? You cannot convert it, and if you see the constants as well, you cannot do it. If n size is 10 and 500, you cannot, any variable cannot store this, right? Yes. Sorry, someone was saying something. Okay, so this is the problem with that solution. I hope you get it. Okay, so never try to do these questions by converting like into integer or long, because that's not the point of this question. It might, even if that works on the portal or something, interviewer's point of giving this question to you is to check whether you are able to perform addition if the number is represented in string or an array. ASCII will come into picture, right? In the case of when you are adding array, so the ASCII was not in picture. So I don't even think this is a hard question. This is should
Sir,
be
every digit को सर ASCII value से कर सकते हैं तो digit को.
हाँ, every digit ASCII value से subtract करके you need to find out that number. For each digit you need to find out the number. Addition will be number, but for every digit you need to convert that, like using ASCII to the accurate number. Like -0 will give you the number that this digit, that this character represents. ठीक है?
बाकी तो array addition की तरह ही होगा.
हाँ, फिर उसके बाद addition करना है, फिर उसके बाद you move to the next character. You add it, and then you find like whatever you get, and you concatenate it at the start of the string, right? So string के start में concatenate करना है. हाँ, I guess now you can do, right? It is, there is a lot of edge cases that's going to be like the complexity is going to be higher, but वो I guess ज़्यादा problem नहीं होगा. Number of, so your n is 500, right? So you can have n to the power 4 as well. That is also going to be fine. Number of digits in a number is 10 to the power 5. ये क्या है? अच्छा, n is the number of numbers you have and the number of digits. So the string length is 10 to the power 5. ठीक है. So you have 10 to the power 5. ठीक है. Now try this one. I guess you will be able to do it. ठीक है. चलो. Anything else? हाँ, I got it. Why did you choose this? 10 to the power 5 size का तो फिर कभी भी store नहीं कर सकते ना. 10 to the power 5 size तो impossible है to store it in any variable. So you cannot do it. 500 strings है for that. So it is 500 into 10 to the power 5, 10 to the power 7 हो ही जाएगा already. So you cannot use string concatenation in between. That is something you cannot do. Append कर सकते हैं, but updation is also again order, and updation is not. Updation in case of string builder is O1, right? You can update it in O1, you can append in O1. So that string builder को use कर सकते हैं, right? Or you can take a character array for output. Yes, that is something also you can do. And its length is going to be the largest string length plus 1. Okay, so largest string length plus 1 कर देना, that is the length of the that going to be. ठीक है, I'll repeat the complexity वाला part tomorrow. What are the things that you want revision? Complexity, theoretical part. ठीक है, चलो, I discussed questions, I gave you ideas. Remaining doubts you can utilize the doubt session. Theory वाला part, what are the doubts? One is complexity that I'm seeing. String के लिए तो we did recently. 2D arrays also we did recently. Array list, all these questions, sorting we solved. ठीक है, so I'll recap everything from start. ठीक है, everything from start, or including memory concept and complexity. So I'll touch everything that we have covered till now. ठीक है, encoding memory, everything, so that you like that would be like an actual revision of touching everything. ठीक है, so ठीक है, I'll talk. We'll have one session at least, right? We need one session. Just inform your batch manager that you need one more session. ठीक है, I'll go. Yes, I'll few topics, for example, the ones that you want little bit more depth to be covered in more depth, so that will cover in more depth. Okay, ठीक है. So I'll tell honestly, this is the first time we have gone a little bit advanced in module 1. Okay, and being honest, I've covered a lot of advanced things over here. So for example, cadence. Today we are talking about KMP, Robin Carr. We saw variations of cadence. We saw sortings, like we saw variations in sortings. We discussed counting sort, which was not over here. So we did a pretty good like amount of advanced DSA. Okay, now don't worry, right? If you are overwhelmed कि sir इतना सारा कुछ पढ़ लिया हमने एक month में, how are we going to remember this, or how are we going to apply all these concepts in the exam? Are we going to get all like questions from all the exams? No. See, model 1 is supposed to be basic. Okay, since you all were doing good, I tried to do little bit advanced with you so that you all are prepared well. Okay, so for example, all these algorithms, a lot of things that we discussed now, if I myself will say, see, I did not have a mentor, right? No one used to teach me, so I used to figure out things myself, right? So I used to do a question, I saw ki ye to nahi ho raha hai. Then I used to search for a video, and then I saw this is something which is a different algorithm. I don't even know this algorithm. I've never heard of this algorithm. I used to learn that algorithm, then I used to forget, then I used to learn, then I used to forget, and this used to happen again and again, right? So it is a long process. Gradually over time, right, you'll remember the names of the algorithm, you'll remember how it is working. It will strike that, okay, palindrome check करने के लिए there are 3 ways that I can either reverse, I can either start 2 pointers from end, I can start a pointer from the center, and I can keep on expanding, right? And you'll get the idea ki where to use what, right? Right now, okay, this might be this can give a higher complexity, let's use this one. And this is again depending on the question, you will the logic that you're applying to find palindrome will vary, and similar it goes for all the other questions like finding substring or anything, right? So that will gradually develop. Right now we have started, so we are just touching the surface, we are scratching it, we are trying to see the depth of the topics. Gradually, as you keep on solving more and more problems, you will improve. Okay, so trust me on that, that's definitely going to happen. That is going to happen slowly, but you'll see your improvement. Acha, from day 1 and today almost we have completed everything, so you all have improved significantly. Tell me honestly, is there anyone who felt that this entire month I did not learn anything or I did not improve? Anyone who felt this? Right, so you all gained something, right? You all learned a lot of things, right? So now see, you all are a very improved version of yourself in terms of programming. You all know a lot of things from what you knew 1 month ago, right? So in same way, you will your skills will develop gradually more and more over the next 4 months, 5 months, whatever you will be connected until you get placed, right? So we'll keep on scaling you up, we'll keep on learning new things, we'll keep on pushing you, right? So memory concept, all those concepts, right, are super advanced, right? So there is a lot of depth to it. Even I also learn things there, right? So there is a lot of memory things that still I am also trying to learn. So that's very depth, right? So I can give you an organized way what you can know for now, what you can think of how things work right now, what the fundamentals is. No matter tomorrow any language changes, the fundamentals doesn't change. Fundamental change नहीं होता language का, ठीक है? Programming language will come and go, frameworks will come and go, but the fundamentals of memory, fundamentals of code, loops, conditionals, it will remain same. If you learn one language to the depth, you can learn another language in just a day or two, and you can start coding in it. That's not a very big problem. People switch to completely different new things. Okay, so all those things will be there, but your fundamental needs to be strong, and that's what we'll focus. Fundamental strong करेंगे, DSL को logic को build करेंगे बहुत strongly. Okay. Sir, is this module used to be easy in past? I would say comparatively, whatever we learned in this batch specifically, I have covered things in more depth, and we went to a lot more advanced questions since I had to repeat very less number of times. So we used to get more time to cover questions. In other batches, what used to happen is I used to have repeat a lot of things because of more doubts. So I felt that comparatively in this batch, we progressed a little bit more depth, right? That batches will also, the things will get covered, but things would get covered to advanced, but that would happen in the next module. So I might have also covered things that are there in the next modules, right? That you might get repeated in the next module. So there you might know, there you will again save few time, and then you will there you will again go to more advanced things, right? that Greek algo is also true. अच्छा Greek algo अभी भी रह गया right? Sevopirus वो भी रह गया. अच्छा चलो ये भी कर देंगे cover. ये आज भी cover नहीं हुआ. ये कल लिखा था मैंने. Why did I miss?
नाम इतना खतरनाक है कि कॉवर्ट नहीं होना चाह रहा है.
ठीक है चलो I'll write this. ठीक है. So this is very easy right? ये बहुत easy algorithm है. Just name difficult है. If you look it up now Google करो बहुत easily समझ आ जाएगा. This is like the easiest algorithm that's there. Out of all the algorithms that we have covered now, this one is the most easiest one. Okay. So we'll cover these two. ठीक है. Buffer we will recap. So we'll recap everything, the things that you want in depth. For example, buffer, strings, time complexity will go in more depth in depth. The things that we want to just recap as the surface. For example, conditional loops. That is very easy for you all now, right? So I don't want to waste too much time there. We can just go through them, overview, and then we'll start with the difficult ones. Cadence is tricky, and even the variations of cadence are tricky. Each variation of cadence is like a different question in itself, and it takes time to figure that out, right? So cadence itself takes time to figure that out, right? Or वो कोई सा like different सा algorithm भी नहीं है, just a small trick, right? ठीक है. Okay. So cadence is fixed, right? So it is like maximum subarray sum algorithm. We call it as cadence, and then there is like sub variations of we call it as variations of cadence, but it's just like all the other logics look like cadence. For example, the one that we use today, right, to find out all the subarrays looks like cadence, but it's this like not exactly any cadence algorithm. For each you don't have to worry for now. You can use like the normal loops for now. Okay, use the normal loops, get used to it. See, normal loops are very powerful. For each loops, you can use them, but there is a lot of things that you can do with the normal loops that you won't be able to do with for each. Right. So I've shared the links in chat for today's notes. I'll share it with the team as well so that this also gets added there. Let me share it again. Okay, so the remaining things we'll discuss tomorrow, and probably we'll try to complete this tomorrow. If not, then we'll might need one more session, but I'm not sure we'll get another one more, but we will get definitely one. Okay. Okay. Thank you, everyone. See you all tomorrow. Good night. Bye-bye. Take care.